Good morning, everyone. We're going to go ahead and get started. Just to introduce myself, my name is Jeff Carlson. I'm the director of the Natural Resources Department here. And we're happy to bring this Nantucket Coastal Conference back after a couple-year hiatus with our partners, WHOI Oceanographic Institute's Sea Grant Program, Barnstable County, and the Massachusetts Office of Coastal Zone Management have been working hard to bring this to you today. And as we get started with that, we'd also like to thank the folks that helped us out financially to make sure we have good snacks and lunch and keep everybody happy. So a big thank you to the Nantucket Islands Land Bank, the Nantucket Conservation Foundation, and the Nantucket Land Council for their support of our programming today. And hopefully we'll have a good time sharing and presenting and learning about all things climate and what's happening on Nantucket, what's happening in our nearby region, and also hopefully a little bit more at a global level. So without further ado, I'd like to introduce Shelley McComb to introduce our keynote speaker. Thanks.
Kind of short. Hi, good morning, everyone. I'm Shelley McComb. I'm the Coastal Resilience Specialist with Cape Cod Cooperative Extension and WHOI Sea Grant. It is my absolute pleasure to introduce Dr. Sarah Doss to you this morning. Dr. Sarah Doss is a scientist and educator at the WHOI Oceanographic Institution. An expert in polar glaciology, she has led over 20 research expeditions to Antarctica and Greenland to document how the polar ice sheets respond to climate change and to understand what the rapid loss of ice means for the rest of the planet. Dr. Doss recently completed 2 terms as a member of the National Academy's Polar Research Board, was an invited expert in the AAAS What We Know Climate Change Project, and is an ambassador with Science Moms, a group of nonpartisan climate scientists and mothers working to give our children the planet they deserve. Dr. Doss is also active in training the next generation of climate scientists. She teaches postdocs and graduate students as a faculty member in the MIT WHOI Joint Program in Oceanography, and also works with K-12 teachers and students, including twice taking high school teachers to Greenland as a part of her science team. She has been a featured climate scientist at the Woods Hole Film Festival, at Climate Science Day on Capitol Hill, on NPR, NOVA, and at the Smithsonian National Museum of Natural History. Despite growing up in landlocked Pennsylvania, Sarah's love of the ocean began early, exploring the tide flats and national seashores while spending time every summer at her grandparents' home in Wellfleet on Cape Cod. Sarah now lives near, but not too near, to the beach in Scituate, did I say that right? Scituate, oh no, Massachusetts, and still gets excited every time she crosses the Sagamore Bridge, even if she's just on her way to work. So without further ado, Dr. Sarah Doss.
Thank you for the warm welcome, and it's wonderful to see so many people here. I'm really honored to have this opportunity to speak to you today about a topic that really consumes me in both my professional and personal life as a climate scientist and a coastal resident. And it's really such an important topic, and it's wonderful to see so many people interested in it getting the attention it deserves. Figured out. Okay, so as mentioned in the introduction, most of my professional work thus far has been as a polar scientist, and that is really what has brought me full circle to being now a polar/coastal scientist. I've spent 25 years working in the poles and really being a frontline witness to the dramatic changes that are happening as the Antarctic and Greenland ice sheets are melting. And they are now the leading cause of sea level rise, and so why we think of the poles as very remote and cold and isolated. They're intimately connected to anyone that's on the coastline, and in fact, the global climate is intimately connected to the polar regions as well. I just want to start with this shot. My talk is not going to be about the polar ice sheets primarily. I'm going to focus much more on sea level rise down to the local scale here. But I just want to give you a sense of some of the work that we do when we're out there on the ice trying to understand these landscapes and how they're changing so dramatically. So this is a shot from some of my work on the Greenland ice sheet in the background. I mentioned from the title here, Snow to Sea, Space and Time. So here I am in the cold ice. A picture of me on the upper right was last May in Greenland, leading some work on the ice. Just a month after that, in June, I was back in Boston sailing with my kids on Boston Harbor. So I went from this sort of icy, cold landscape to back to the beach here. And we think of these places as requiring, international travel or months at sea to get to. But as a geologist in my own training, I also understand that even where we're sitting here right now, if you could be a time traveler, you could also be back 20,000 years in time, that person up on top of the ice sheet that was sitting on top of this part of New England during the last glacial maximum. And so we also have to think of these climate changes in both space and time. So they're happening spatially now, but in time, everything is transitioning. Nothing is really static. So what difference does a few degrees make? As climate scientists, we often say, we need to keep things within a 2-degree threshold or a 3-degree threshold. And maybe that seems like a small number if it's 65 degrees outside versus 66. You think nothing of it, right? But these are global temperatures and global averages. And a matter of a few degrees is really what makes the difference between where we're sitting here, looking like Greenland, as it was 20,000 years ago, or 10,000 years ago, this landscape, still not coastal, covered by boreal forests and wetlands like you might see in the Arctic right now, to today, this beach and nice summer day. And this is globally just a matter of 4 or 5 degrees difference. So that's the zooming way out in space and time, 20,000 years from Greenland to here. We can zoom in a little bit closer in time and think about global temperature variations just over the last 2,000 years to sort of place us in perspective of where we are right now. And temperatures, as indicated in the colors here, there's no real time or scale on this, because what it is just supposed to illustrate to you is that we've had relatively cool, stable temperatures for most of those 2,000 years, up until essentially the Industrial Revolution, where we started burning fossil fuels for many good reasons at the beginning. And at the same time as that black line, which is showing global carbon dioxide levels changing over time, you start to see these temperatures make this rapid increase, bringing us to the place we are at present. And this matters a lot, and it's really an important piece of the sea level conversation, because the sea around us is rising in direct response to these warming atmospheric and ocean temperatures. We can document sea level rise over space and time. Right now, we can document it very, very well using satellites, but that's just been for the last few decades. Prior to that, we could use tide gauges. Prior to that, we could use other sort of geologic indicators of where the coastline was over time. So if we look back at, say, about 100 years of sea level rise, again on the global scale, we see that it has a lot of wiggles, but generally has been on this upward trend. What you can also notice with the overlap here, where the satellite era began with the tide gauges in black in the background, is this increase is starting to really accelerate. And that is primarily due to the fact that temperatures have now warmed sufficiently that we're starting to melt in greater and greater amounts and faster these large ice sheets in the Antarctic and Greenland. Another really important component of this sea level rise is the ocean itself is absorbing an enormous amount of the heat that's being trapped in our planet's atmosphere. And when the ocean absorbs this extra heat, it expands. It expands both at the surface, but also at depth. And so now that we have these higher resolution spatially and temporally observations of sea level rise and of this sea surface height changes, we can start to tease apart a lot more of the kinds of mechanisms of what's responsible for these changes. And so now we're looking just in the last few decades in this figure, from the early 1990s through to the present. This black line, again, is the satellite-derived global sea level And you see these two lines under here, which are essentially just indicating which components, if you add these two up, you'll get to this higher point. And what you'll see are these two components, the thermal expansion, so that's due to that ocean absorbing that excess heat, as well as added water, and this is mostly meltwater from mountain glaciers, say from the Alps or Alaska, as well as now these larger ice sheets. And you can see that in the early 2000s, those two components were fairly equal in their magnitude. But as we've moved through the last couple of decades and the atmosphere has continued to amplify the warming, in particular in the Arctic, you see that this ice component, this extra water, is really starting to take off. And when we think about projections into the future, and we start to talk about accelerating sea level rise that we're observed and we're predicting, we're really, while we're going to continue to have a component from the ocean expansion, the real wild card here comes to what are these large ice sheets doing in response to warming. I'm not going to spend too much time on this here, but it's important to note, and I'll touch on this in a couple other figures as well, that of course the sea is not a bathtub. It doesn't rise evenly everywhere. So while there may have been sort of 8 inches or so of global sea level rise last century, in an area like this, you're seeing more like a foot or more. And that's because you have regional factors that are really important to amplifying what a specific coastline sees when it comes to local sea level rise. So you can think about the ocean filling up more from adding ice melt, but that is not evenly distributed. Where that ice is coming from actually affects the gravitational pull of the ocean towards either pole. And so the ocean isn't flat on its surface as well. You also have land movement. So the land where we are here in the Northeast is actually subsiding with time. And so you have an additional relative amount of what feels like sea level rise because the land itself is sinking. There are places, some parts of Alaska and Greenland, in fact, where the land is rising. It was pressed down so much by the large ice sheets in the past that it's starting to rebound. So that's a very important component as well. And then you have all sorts of things that are happening with the ocean itself. The surface ocean is responding to winds and waves and currents. And especially on a year-to-year basis, and definitely on a storm-to-storm basis, that makes an enormous difference in terms of how any particular locality or region is experiencing sea level rise. So we talk about climate change. Many facts and figures and stories are focusing on these global numbers, global scales, but as anyone knows, we experience climate change locally. And while I'm mostly going to talk about sea level rise, I think it's important to point out that while the planet is warming, there's many other effects that are impacting all of us, coastal communities included. So with sea level rise front and center in coastal Massachusetts, we're very aware of things like flooding and erosion and changes to ecosystems. We also see rising ocean temperatures around the world, which impacts all sorts of things from storms to fisheries. We see really big changes in precipitation events, more droughts and more floods sometimes in the same places. And then we're also seeing changes in storms. So just as an example here, now we're looking at Massachusetts on the left. These are just 2 months separated just from last fall. Massachusetts drought status, including down here on the Cape and the Islands. Many of you are probably aware we've been experiencing summer droughts regularly here in Massachusetts. So we have this sort of overall drying trend, but on top of that, this is I found on the town of Nantucket's Twitter site. When we have droughts, we can also have extreme precipitation events. So you can have this kind of whiplash effect where you have a longer term drying and then extreme weather and rainstorm events that can also lead to flooding. And that is consistent with the models and predictions that this will intensify going forward. So we can talk about global warming, but of course we're experiencing warming again in our local regions. We just focus here on the northeastern US. You can see that in particular the sea surface temperatures are getting much warmer even relative to the rest of the planet's warming, as well as the land surface. And these temperatures are anomalies, so extra heating based relative to this 1950 to 1980 average in degrees centigrade. So almost all of the planet is warming, and some areas warming much more than others. I'll just point out one of the other things you can really notice here is the amplification of warming in both the Arctic, across the Arctic, as well as parts of the Antarctic, which leads to extra ice melt. And this is just to illustrate again that changes in sea surface height are not smooth. We're not sort of talking about a bathtub situation. You have a lot of variability spatially in the height of the sea surface around the world. Okay, this is meant to be a provocative map. This is what coastal Massachusetts, Cape and Islands would look like without any ice. So the blue is underwater. Here we are sitting right here. Here's where I work in Woods Hole. Here's where I live in Scituate. I'm not safe anywhere. You're not going to see figures like this. There aren't really projections that we're, even when we're trying to be very alarming, suggesting that we're going to see this scale of 70 meters or so, 200 feet or so of sea level rise, or melting all of the ice. But it gives you a sense, I think it gives you a good sense for how much potential sea level is locked up just in these two large ice sheets, the Antarctic and Greenland, that it could so dramatically change the entire coastline, make it unrecognizable. Now we can go back in time and think, well, what did the world look like in the past when we had carbon dioxide levels similar to where we are at today? And this is a really important tool that geology can bring to climate science, is to go back and say, are there analogs for the future that we're headed towards or the future that we're in? Can we use this understanding of how the planet responded in the past to see what we might expect in the future to help test some of our models or to help prepare? And indeed, we find that in the mid-Pliocene, about 3 million years ago, sea level was about 25 meters higher. And in fact, people have mapped on this right-hand side, this is the east coast of the United States from Cape Cod down Florida and to the Gulf of Mexico. And people have been able to map this paleo shoreline, showing very strong evidence for where the ocean was. So while I say we're not headed here, there is an analog for this world without ice that is in line with the kinds of emissions that we're experiencing right now. So I'm going to talk a little bit about the future, what we know, what we don't know, and what that means for places like Nantucket as well as globally. And this may be a curve that some of you are familiar with. This is sea level change relative to 1900. So 0 is fixed at the 1900 point, going forward 100 years. And this is kind of a standard, scenario to 2100 type figure you may have seen or you may see again. And what you can see is that there are a bunch of different colored lines, and they are what we call different emissions pathways, or now by IPCC called these shared socioeconomic pathways. And you don't need to focus on these numbers or letters or anything. What really I want you to draw away from this is that sea level is rising, duh. It's accelerating. For the next few decades, these lines are fairly close together. The spread of what we are expecting is not that dependent on these different emission pathways, sort of what our carbon budget is going into the future. We're expecting an acceleration. It's really past mid-century or so that you start to see a wide divergence in these scenarios. And again, these are global numbers, but you can do a similar exercise for Nantucket in particular. So this is based on a really recent US Interagency Task Force report. This is specific to this location where we are now. So now you see the historic trajectory of sea level, and I will apologize that, this is in meters. on the y-axis, and now we're in feet. Sometimes I think it's easier for people to grasp the future in their location in feet. But so we're presently around here, and you can see this interannual variability, and that gets at really some of these subtler changes that any location is experiencing. So you're never going to see a smooth sea level acceleration curve for one location. You may see that globally. But we're kind of committed to mid-century to, 1 or so feet in this location. We have choices to make beyond that point, whether a place like Nantucket is going to be experiencing 2 feet, which is sort of, the best case scenario, 4 feet, it's kind of the pathway that we're on right now, 6 feet or more, possible. But why is there such a spread, right? Why can we not say, with all the science that we're doing, all the research we're doing, all the tens of thousands of committed people spending every day working on this? Well, a lot of it is because we can't really predict the future. We, as nations, as individuals, as the world, have to make choices about how warm the planet's going to be. And because ice is very, very sensitive to a little amount of warming, and we know this because this is how the ice sheets have behaved in the past, and it makes sense. It's really just basic physics. The warmer the atmosphere is, the faster the ice is going to melt. So if we don't know what temperature trajectory we're on, we can't tell you how much ice is going to melt. This is an illustration of the mass loss from Greenland over the last 20 years or so. So this blue line is the change in mass. This is measured by satellites, actually. And you can see as we move through, and we're now about halfway through 2010, the red colors are indicating mass loss cumulatively. So this is what's happened just in the last 20 years or so to Greenland. And you would expect this trend, and in fact, we see this trend continuing and accelerating as warming continues. Similarly happening in the Antarctic, it was a little slower to start, so you don't really see this drop off till 2010 or so, whereas Greenland dropped straight away. But the same thing's happening, and we expect to accelerate in the future. Now, this, of course, is a crisis around the world, not just where we're sitting. Hundreds of millions of people live below the projected high tide lines for both the middle and high emission scenarios. Coastal communities, as we all know, are very vulnerable to flooding. So I'm now going to sort of transition from talking about sea level rise to flooding, because how do we experience sea level rise? We experience it as loss of our coastline and flooding. And we're used to talking about extreme events, named events, big storms that make the news, at least for a few days. They attract disaster agencies and lots of money, hopefully, to clean up, and then people move on. And 2 of the biggest storms that we've experienced here in New England happened last century, and they're sort of things that are passed down in family lore. This is a photo I found, which was remarkable, is a house from Bourne, which got swept all the way down the canal and got stuck up along the Bourne Bridge. But increasing concern, and in particular for areas such as Nantucket and much of the Cape, are these recurring or tidal flooding events. And these are just some photos illustrating this kind of flooding around the country recently. And this is also called nuisance flooding. Essentially, what's happening is that we're creating a new normal, a new high tide over time. As that baseline sea level rises, we're starting to see flooding, or we're starting to see water level pass these flood thresholds to the point where they're really impacting infrastructure and people's livelihoods regularly throughout the year. So it doesn't even take storms. I'm going to skip that. Oh, no, I'm not, because I have to bring the next one. So we are at risk from flooding because we have physical things and people that are in harm's way, right? If we didn't have anything on the coastline, we wouldn't think of it as a disaster. So we have infrastructure, and then we have the surrounding changes in the ocean, groundwater, the land subsiding, storms all layered on that. But we also have human factors, and this is a really important component as we make decisions going forward as well, which is that studies are increasingly showing that changes in development and population change are increasing flood risks, outweighing climate risks, in some places fourfold. So even if we get a handle on the climate scenarios, if we are not making changes to how we protect people and our investments in communities, we're increasingly moving people, even today, into harm's way. And this impact is borne disproportionately by poorer communities across the United States and the world. So I had a little fun with this figure. I don't know that much about Nantucket, but I learned a lot preparing for this talk. How do we live on a coastline? How can we think about living on a coastline that's in change, right? So if we think historically, like way back to how people lived in landscapes like this in coastal Massachusetts, and we have over 10,000 years of the native Wampanoags living in this area, starting when this wasn't even a coastal area. So the ice had retreated, but the sea level had not yet encroached all the way. And there's evidence of lots of human activity, of migrations in and out of different regions, but living very lightly on the land, not having fixed places, not really thinking of the coastline as a point fixed in time. If you could imagine being here for thousands of years, and that sea is many tens of miles away. Over the last few thousand years, this became coastal communities, but even so, the people that lived here really treated, as far as I can tell, the coast was a place that you would go and use the resources or use for transportation, but it wasn't a place fixed necessarily, and so it would be much more adaptable to a changing coastline as climate changed. The early English settlers, this apparently is the oldest home in Nantucket, as you all probably know, from the 1600s, started to put things fixed in place, and also the idea that one might own land and one might draw a coastline and expect that to stay fixed in place. That kind of mindset came and is carried through to today. But even then, a few hundred years ago, communities tended not to build right on the coast. They recognized the hazards associated with that, or the weather perhaps was too extreme. To today, where of course, who wouldn't want their house to be on the waterfront? I mean, that's the most desirable place in many coastal communities. But that really results in being right in that frontline risky area. And it also drives home the point that if we think of the coastline as fixed, whereas the reality is it's always changing, we need to figure out how to adapt to that. And that's what the future will hold. So I just want to touch a little bit more on flooding. This idea of flooding being really, in addition to the storms, something that's going to be driving a lot of the response and decision-making that communities like Nantucket are going to need to face. So this is a projection that the NASA sea level team, which my colleague Chris has led a lot of this work on, has put out. They have a really wonderful website if you want to go dig around, and there's a lot to play around with there, sealevel.nasa.gov. But again, this is specific for Nantucket, and what you're seeing here is a projection, so from today, or today here, in these flooding days, so these are minor tidal flooding events, and right now there's about 6 per year. Looking out just till the end of this decade or so, that number is expected to quadruple, which if all you saw was that, I suspect that in and of itself would be pretty alarming. But as you look even farther out down the line, you see that this number of flooding days per year really starts to ramp up. Well, we'll hold on to your hats because now we're looking out towards the end of the century. So here we are today, here we are quadrupled, and now we're looking by middle of the second half of the century, we've created a new high tide, right? So we have almost every day of the year exceeds this minor flood threshold. This is under the intermediate temperature scenario, so a little bit more optimistic than where we are right now. One thing to really note is this period of what they call inflection. So we have this slower change here, really just for the next decade or two, and then it starts to really ramp up. And as I pointed out in the earlier figure of the sea level projections, you see that there similarly as well. Sea level is accelerating, but then really mid-century is where it starts to take off. And if you remember, there was a spread in those projections as well. So this is the middle scenario. This is for the high temperature scenario. So you're just moving that whole period at which you've redefined what a high tide is, even closer to today. So I just have a couple more slides. I really want to just drive home the point that I think this is such an important decade for setting the stage for what's to come, both at the local level and the global level. This is a really nice graphic that was in the last IPCC report, which uses what we call warming stripes. So we have over the last, so this is about 200 years, so 1900 today to 2100. And the colors indicate the global temperature change above this baseline level, 1850 to 1900. And it's here to illustrate essentially different generations of people, what's in a decade, right? So I think about when people in my family were born. My mother was born in the 1940s. I was born in the 1970s. You know, it wasn't that different, a little bit of warming, not that dramatic. But then things start to really pick up. My kids were born 15 or so years ago, so we're starting to see warming here. And then moving towards today and looking into the future. Now, my kids are teenagers, so I shouldn't say I'm looking forward to grandkids, but I kind of am already. But what kind of world are they going to be in? So we have, again, towards mid-century or so, these colors are very similar. They're all warmer quite a bit than today. No one born today or later will ever know the world that I grew up in terms of the temperature or the climate. But what world my children and grandchildren will inhabit divides dramatically based on what temperature and emission scenario we follow going forward. Okay, these are a lot of words, but that means I'm almost at the end. I tried to make this fewer words, but I had a lot I really wanted to end with. So again, I think this really is a decisive decade for coastal communities. As I've shown, sea level is rising at an accelerated rate due to the ocean warming and the ice melting. This accelerating sea level rise is also creating abrupt increases in flood risk, both frequency and magnitude. So this is not just storms, which we expect to amplify, but also these tides alone. This has an inflection point in the early 2030s. Up until now, many coastal communities could get by with a business as usual for planning and be reactive to disasters. In my view, this will become increasingly untenable or unaffordable or both, with every decade making that harder and harder as we move through the 21st century. Most of our infrastructure decisions, where are we placing our next school? Where are we placing our water treatment plant? We're dealing with that in my town right now. Where are we going to put our wastewater treatment plant? All these things every community faces. We need to plan those looking out beyond a decade or two to an entirely different world than one we're living in. We really need to be proactive about thinking about the threats and hazards that will be facing that infrastructure, as well as where people are living. Sea level trajectories through mid-century of about a foot or so are relatively well constrained, not that sensitive to future greenhouse gas emissions. We know we have about 2 feet of sea level rise in the most optimistic scenario for this part of the US coastline. But it's that post-2050 scenario, whether, again, a place like Nantucket is on a path for 2 to 6 feet range, is highly sensitive to the decisions that we as individuals, as nations, and globally make this decade. So hopefully can end with a little bit of well, I don't want to say optimism, but I feel like being able to take action always makes people a little bit more resilient. We are all collectively, in whatever role we play, the solution to coastal resiliency. We can take individual actions. If we're a coastal homeowner, we can prepare for rising seas. We can work towards, say, greener solutions for coastline change. As a community, the kinds of activities we're doing here are so important: gathering, talking, making decisions. This is that nice park right down on your harbor that was built with sea level rise and resiliency in mind, allowing for water to flow and ecosystems to thrive. And then at the national and global level, this is global mean temperature by 2100 from 1.5 degrees. You've probably heard about the Paris Agreement. We'd all as scientists like to stick to this number, or maybe 2 degrees, to prevent the worst catastrophic effects. Right now, the policies and actions that we're following have us closer to this 3 to 4 degrees. Many countries and internationally have made pledges and targets that get us a little bit lower. Ideally, we'd like to get, and the US has signed on to this as well, to net zero by 2050. But what that really means is that we need to have reduced emissions by 50% by 2030 to get us on that path. You sometimes hear about emissions being drawn down, maybe into the ocean or into land, things like that, and that's going to be an important piece. But the problem with sea level rise or ice melt is if you overshoot these initial targets and then draw it down, you've already melted that ice, you've already raised that sea level, and you're not going to be able to put that ice back on land. So we really need to try to hit this, what people call 50 by 30 target on our way to net zero by 2050. Thank you.
We have time for 1 or 2 questions, and you can come up to the podium or this mic, thank you, and speak in that. This is being live streamed, so we want people online to be able to hear the questions and the answers.
Good morning, thank you for the presentation. Just a question, have you heard familiar with Dr. Howard Dryden, PhD marine biologist out of Scotland?
I'm not.
Dr. Dryden proposes that climate change is primarily driven, not specifically by CO2, but also by the pollution of the marine environment and the degradation of the surface microlayer, SML layer on the oceans. And the restoration of that health will impact our chances of controlling climate change greater than production and emissions. But I just didn't know if you had a comment on that, given your understanding of marine biology.
Well, I'm not familiar with that particular theory. I guess I'll make 2 points. I think the marine ecosystem is vitally important to a sustainable planet, to fisheries, and to the oceans being able to continue to absorb the amount of carbon that they're absorbing now, which is really helping us not see extreme temperatures right now. The idea that would play a larger role than emissions, I don't think is founded in solid science. We have, over millions of years, established a very, very clear relationship between the greenhouse gas concentrations in the atmosphere and temperature. And we understand that intimately, and the physics of it is fairly straightforward. And in fact, models that have been run over recent decades have predicted almost exactly the temperatures globally that we're seeing now in response to the emissions that we have added to the atmosphere.
Thank you.
Yep.
Also, thank you for a very informative and depressing presentation. But going from a kind of big question to a very parochial one, I had read earlier that we in the Northeast are enjoying, unfortunately, a higher speed of sea level rise, et cetera. And you said there were some, regional reasons for that. I was wondering if you could just expand on that a little bit. Thank you.
Yeah, absolutely. So one of the primary ones is this, this isostatic component. So the fact that along most of the Northeast U.S. as well as the Gulf Coast, the land is subsiding. So you have the background sea level rise. Even if sea level was stable, it would appear relatively to be rising because the land is sinking. So that's amplified in the Northeast. And then you also have a confluence of factors in terms of ocean circulation and atmospheric variables that essentially conspire to make the Northeast one of the bullseyes of elevated sea level rise. Yeah.
All right. Hi, everyone. My name is Leah Hill. I'm the town's Coastal Resilience Coordinator. I will be the modifier for this particular topic. It's around the Cape and Islands. So our first presenter is Shannon Hulst. She is a floodplain specialist for Barnstable County, Massachusetts, with Cape Cod Cooperative Extension and Woods Hole Oceanographic Institution Sea Grant. She is a certified floodplain manager with a master's degree in marine affairs from the University of Rhode Island. She provides technical assistance on all things related to flooding to communities, residents, and businesses on the Cape.
Thanks, Leah. Can you all hear me okay? Okay, thank you. Some nods. All right. So as Leah said, my name is Shannon Hulst. I am the floodplain specialist for Barnstable County, and today we're going to go from the exciting, larger picture thought of sea level rise down to the really, really minuscule here and talk about bylaws, really exciting things. So I'm going to talk about some things happening on Cape Cod, and hopefully you can all be thinking about how these might be able to apply to Nantucket. So first, there we go. Want to go over some basics of bylaws. I'm going to be talking about 3 different bylaw projects that we have going here, and just want to give you some context for how to think about this. So 1, bylaws regulate activities in our floodplains. So Sarah just did a great job giving us an overview and helping us think about what is coming and the flooding we're going to start seeing. So what do we do about that? That's what we're trying to address here. So we're regulating our activities that are happening in our floodplains. One of these bylaws that I'm going to mention is required for participation in the National Flood Insurance Program, or the NFIP, which means if anyone is going to have access to flood insurance through the National Flood Insurance Program, the towns have to do this. Or I'll be talking about higher standards. So again, we've got 3 different projects going here, and some apply to the NFIP, and some are higher standards beyond that. I'm only going to be talking about actions that are not covered by the Building Code, the Wetlands Protection Act, or other state regulations. This is only things that we're doing at the local level. And then finally, I'll be talking about zoning or general bylaws versus wetland bylaws and performance standards. So I'm going to start with a new statewide model floodplain bylaw. And this is, so it's new. Why a new bylaw for all of our National Flood Insurance Program communities? So this is all communities in Massachusetts except for 11. So I think it's 342 communities in the state, including Nantucket, this applies to. So the National Flood Insurance Program, again, has certain requirements. If anybody in town wants access to flood insurance, if anybody in town has a mortgage and they're in a floodplain, they have to have access to flood insurance in order to get that mortgage. So these are things that were supposed to be in effect nationally since 1978. And on Nantucket, it's since 1980. That's when the town joined the National Flood Insurance Program. So these are things that we were supposed to be enforcing for a few decades. All of our communities were missing items. Certainly our Cape Cod communities were not enforcing all of these. I'm sure that Nantucket is not enforcing all of these. That's just kind of the way that it goes. Nationwide, that's happening, but working with FEMA and the state, we're trying to clean that up so that we're actually meeting all of the federal regulations that we are required to do. So just a few items that are common that have been missing on the Cape. designating a floodplain administrator so that when FEMA comes to town to talk about what kind of development is happening in the floodplain, and if you're enforcing things properly, they have someone to go to. Recreational vehicles, I don't know how much of an issue this is going to be on Nantucket, but there are certain rules that apply to recreational vehicles that are in a floodplain. There have to be permits for all floodplain development, and development here is defined really, really broadly. There have to be local requirements. When the Board of Building Regulations and Standards issues a variance, that gets into really detailed stuff with the building code, but there are some things that the state has control over, and then things that the locals are supposed to do, and then also some other variance language for the local regulations. So that's just a really quick overview of what's in there. I don't believe Nantucket has done that yet, but that will be coming. But there won't be a big change to the way things are done now. It's mostly how things are done on the town side. So moving into higher standards. So we're going to start with zoning. So we've done 3 different projects now, and we've coordinated this project. It's been Cape Cod Commission, Cape Cod Cooperative Extension, Woods Hole Sea Grant, Urban Harbors Institute with the University of Massachusetts, Boston, and then Noble, Wickersham, and Hart is the law firm that has been working with us. Nutter Law also worked with us on part of this. So we've had lots of different partners in these higher standards components. I'm going to talk about zoning, and this can also be general bylaws first if you really know planning and you wonder, you're thinking, oh no, that should be in general. I have had that happen. I know it's rare, but it has happened. So we're going to talk about zoning first, and then we'll talk about wetlands bylaws and performance standards. So first, why higher standards? So Sarah just gave us a really good reason for why we need higher standards. So we're going to have increased flooding. We need to deal with that in some way. So resiliency and climate change is the #1 reason to have higher standards. Safety. If we have development, if we have people and property in harm's way, then we are going to have risks to human health and well-being. So we want to reduce those risks. We want ease and transparency of enforcing existing regulations. That's another thing that gets really into the nitty-gritty of enforcing some of those things in the building code and the National Flood Insurance Program regulations that are already required by the federal government. That's coming from me working with our building commissioners on the Cape for 8 years and hearing from them all the things that come up that they need help figuring out how to deal with. And then same thing with common issues. And then another thing is also flood insurance discount. So there's something called the community rating system. 9 of our towns on the Cape already participate. 3 more are in the application process. This is a program within the National Flood Insurance Program that a town can opt into and earn discounts on flood insurance in exchange for these actions that improve flood resiliency. So these bylaws, these higher standards, can help earn credit in that program and earn those discounts. If Nantucket were to participate at the same level that the other Cape Cod communities participate at, then the savings would be about $200,000 a year spread across 1,000 policyholders. So that's a really big number compared to especially our Cape communities. So it's certainly something worth thinking about. Okay, so sorry, there are a lot of words on here, and I'll try to go through these quickly. So in our zoning in general bylaws, so again, higher standards here. So some of the things that we're proposing, the intention is for this to be an a la carte kind of thing, and have communities be able to pick and choose what they want and what works for them. So a few of the things that we're proposing, this is not an exhaustive list, but it gives you an idea. So we've got a potential prohibition on new structures on vacant land in high-risk flood zones, which would be V and coastal A zones, for those of you who know your flood zones. Prohibition on certain types of structural fill. A limit on the expansion of the structural footprint, because we don't want to keep increasing the density of our development. Building and elevation heights, building elevation and height baselines from design flood elevation instead of grade, which means basically you're not punished if you have to elevate your house a lot because of the floodplain regulations. You can still have a higher structure. That one is not, some towns love that one, some towns hate that one. So again, this is a la carte. Limitations on reconstruction after substantial damage. If we've had a structure that's been damaged over and over by coastal storms and flooding, then maybe we need to reconsider whether or not that structure should be able to be rebuilt there. Guidance on addressing qualifying historic structures. This is a big one for Nantucket. We have been working with you all on the work that you've been doing on historic structures at risk of flooding, and we're leapfrogging each other as we go here, trying to figure out, you all have figured out some things here on Nantucket, we've figured out some things on Cape Cod, so we're trying to help advance that and make it really clean for our building commissioners to enforce the floodplain bylaws, but also and regulations, but also allow for some leeway with historic structures. Added safety measures and limitations on accessory structures. This is one that really slips through the cracks. If an accessory structure is being used as a small Airbnb or something, we want to make sure that that is a safe place for people to be. Low MRF land limitations, that I'm just going to skip that one. That's a really detailed one. Non-conversion agreements, these are fantastic. I love these. When you have a new structure or a substantially improved structure, you've put in 50% or more of the market value, and you elevate it. If you have a full story underneath that house, it can only be used for parking, storage, and building access, but people love to finish it off once they've got their certificate of occupancy. They don't get permits for it, and then it gets flooded, and that's usually where people put their in-laws, and it's not great. Maybe it depends how you feel about your in-laws, but generally not a safe place to put folks, especially who are older and might need assistance with moving. Storm surge can come in really, really fast and really take people by surprise, so it's a really, really big risk to put people in that space. It's not allowed per the building code, so what this non-conversion agreement is your contractor and the building owner sign this letter saying they acknowledge they are not going to finish that space off after the building commissioner and his certificate of occupancy go away. So I really like that tool. It really improves our safety. Prohibition on storage of hazardous materials. This is a big one that's kind of slipped through the cracks. Everybody's got gas cans in their shed. We've got propane tanks for heating, and there are certain rules with some of these. And certainly we want people to be able to still heat their homes and mow their lawns and everything. But we want to look at how we actually store these things in the floodplain, so that if we get a flood, we don't have loads of gas and oil floating around in our water, because the biggest cause of damage in a flood after actual water is fire. Because you have oil and gas in water, you have electric lines down, they spark, they light things on fire, even though the oil and gas is in water. That's how a whole neighborhood, Breezy Point, Queens, New York, burned to the ground during Hurricane Sandy, even though it was surrounded by water for this reason. And then finally, special permit considerations, if those are applicable to your community. So that was really fast, going through the zoning and general bylaws. We're going to move to wetlands here. So we did try to coordinate these two, but we're still working on that. This is a graphic to help you kind of visualize what we're trying to do here. So we're trying to look at the potential for expanding our floodplains beyond what FEMA gives us right now. Right now, we're stuck with what FEMA tells us is the floodplain. FEMA's floodplains are backward looking. They do not consider sea level rise, so we want to start looking at that. So these different zones, you do have, you've got land subject to coastal storm flowage is the floodplain, is the FEMA floodplain. It's just in wetland speak instead of FEMA speak. And then we've got some different higher risk zones there. And then we have what we're calling the coastal resiliency zone that looks beyond the FEMA floodplain. Then we have highly developed areas and that are already developed, and then special transition areas for wetlands and other coastal resources to be able to migrate with sea level rise. So we have regulatory zones, we have discrete zones, we have regulations that apply to discrete zones. We've got V zone, coastal A and A, those are all FEMA designations. And then that coastal resiliency zone that I'm going to show you again in just a second, and then again that special transition area. And then the redevelopment sites and highly developed sites overlap those zones. So the coastal resiliency zone, we are saying, is going to be taken from the best available science. Right now, that is the Massachusetts Coastal Flood Risk Model. We didn't want to put that into the language because we want these bylaws to be able to be adaptable with any new products that come out. So right now, you can see this area kind of shows new structures that are not in the floodplain right now, but would be if you look at either 2030, 2050, or 2070, and different sea level rise projections that have been chosen for those years by the team that put together the Massachusetts Coastal Flood Risk Model. This model was just released to the public within the past few months. There have been some trainings on them. I still have to do the last training. So we're all still kind of figuring out how to use these. No communities have adopted these yet, in part because this data was not available yet. But now it is, so we're able to move forward with this. Some options that are applicable to all locations. So we want to maintain existing flood conditions and natural features. We don't want anything to channelize floodwaters, so that's going to apply to fill and structures. Prohibiting new or expanded buildings. So again, some echoing from the zoning concepts. Prohibiting reconstruction after repetitive loss or substantial damage, still echoing that. And then we're going to use a target year, which has not yet been pulled into the zoning because the maps were not done yet when we were pulling that together. So again, using 2030, 2050, or 2070, I would say now 2030 is, we're already too close to that, so I expect communities will go with 2050 or 2070. And then again, based on the best available science. And then elevating buildings 2 feet above the current base flood elevation or above the base flood elevation for the target year, again, depending on the maps. This will get clearer in these regulations. And we're also making sure that they coordinate with the latest updates to the building code. We have a new pending building code that increases what's called freeboard, so how high above that expected level of flooding we have to elevate based on the flood zone. So we're working on this again, and we're now creating performance standards to go with these so that so the conservation commissions can really fully enforce these. So we have an opportunity to take a look at them again and make sure they are up to date with everything that's being released by the state. In the special transition areas, so again, these are predicted paths of wetland migration. We want no development at ground level. We want, to the greatest extent feasible, no septic systems. We want vegetated areas preserved and expanded, impervious areas minimized. Those are all pretty logical. Developed areas, redevelopment sites, we want people to improve existing conditions. So reducing impervious surface, restoring or creating wetland resources, don't expand an existing footprint. And then highly developed sites, fill and seawalls or berms would only be allowed where applicable per state regulations as part of a flood control program. So you've got to have a bigger concept going on here if you want to have those things. Next steps, the project completion for creating the performance standards is early 2024, and we're going to continue to coordinate between all of these bylaws and state regulations that are now coming up so that we all have the same information, and then we will start to work with communities to adopt. So if this is something that Nantucket is interested in, or any of these pieces are things that Nantucket's interested in, we can certainly help you with that as well. Just quickly want to acknowledge, I mentioned all the partners, but these are all of our partners across 4 projects. The additional project was the statewide model bylaw, which FEMA and the Department of Conservation and Recreation were heavily involved in as well. And with that, I will say thank you for your time.
Microphone, but you will repeat it so that the live stream can hear.
I'm wondering if you can elaborate a little bit on the recreational vehicle requirements.
Yes, so the question is, can I elaborate on the recreational vehicle requirements? Yes, so an RV in a floodplain can only be there for 180 days, or it has to be licensed and road ready, or it has to be anchored and elevated to building code standards. And that is a new one for everybody. I don't think any community in Massachusetts had that in their bylaws yet. We're going to have a little bit of a hard time with that on the Cape, but okay, thanks everybody.
And we encourage you to ask questions to presenters during the breaks. It is my honor to introduce my former colleague, Thais Fournier. She used to be the water quality specialist here on island. Thais joined URI's Coastal Resources Center as a coastal resilience specialist in 2023 after her previous role overseeing the town of Nantucket's estuarine monitoring and research program. With a background in coastal ecology and a strong commitment to outreach and education, Thais has worked on conservation projects in New Zealand and studied the impact of climate change on terrestrial communities in Mexico. She holds a BS in biology from the University of New Hampshire and an MS in marine science from the University of San Diego, where she focused on habitat connectivity and coastal areas. Thais is also an avid polka dancer and attended the annual Thank you, Polish Festival over the weekend.
Hi, everyone. Thank you for having me. I always like to throw in a fun fact in my bio, but it's not really a secret talent, but I do polka. So anyway, so thank you, Leah, for the introduction. So I'm from the Coastal Resources Center. It is nice to be back on Nantucket. In my previous role, there has been a lot of overlap between water quality and coastal climate impacts, so there's been a lot of exchange. The center that I'm from is from the Coastal Resources Center. We're also Rhode Island Sea Grant Extension, and so we focus on sustainable management of coastal resources. So I am in the Coastal Resilience Program. However, the center does focus on offshore wind energy, aquaculture, and just helping these communities build capacity to respond to different issues in Rhode Island. So this is just an example of us working with a different community in Rhode Island to help them deal with their impacts of sea level rise and storm surge. So although I'm probably the odd one out here from Rhode Island, but as a small state, we do have 30 plus islands. It kind of depends on what you consider an island. A lot of them are inhabited, but we do have about 400 miles of coastline, and so we have a lot of similar issues that we're obviously experiencing on Nantucket as well. So I'm happy to come here and share about the things that we are doing for Rhode Island coastal communities in hopes that maybe this may stem some ideas for Nantucket and just sharing different resources. All right, like I said before, this is Rhode Island, and we do have over 30 islands. We do focus on not all of the communities of Rhode Island. We do have the capacity to do that, but we focus currently right now on the 21 coastal ones. So this is just an example of really highlighting the different areas, and our center is based on the South Shore in Narragansett. So again, having 400 miles of coastline, we are at a large risk to impacts of climate change, specifically our sea level rise and impact of storms. So some of these examples I put up here from the 1938 hurricane. This is a picture in Providence, Rhode Island, to Superstorm Sandy, which is in South Kingston. This is a photo. And then an extreme high tide event, which in Newport, Rhode Island. We're also seeing increased temperatures, and this is due to air and water and how they're affecting these storms. We're getting increased storminess, more intense and wetter storms, as well as an increase in hurricanes, nor'easters, and heavy rains. Our impacts are accelerating. We have seen a 12-inch rise since 1930, and we're projected to have an additional 12 plus inches of sea level rise projected in the next 30 years. And a lot of our damaging floods that we see here on Nantucket, as well as Rhode Island and other coastal communities, are projected to be 10 times more often than present. I realize the trajectory of all of our presentations haven't been the most uplifting, but I will get there. Storms are like ferries. There's always another one coming. For those of you who are familiar with Richard Branson, who is the billionaire founder of Virgin, the quote was, "Opportunities are like buses. There's always another one coming," but since we're on Nantucket, I figured it would be applicable for me to change this quote. So how can we prepare and become more resilient when we know another storm's coming, or when we're seeing this, depressing fact of sea level rise increasing and our climate really changing? This quote was taken from Resilient Rhody, which is a comprehensive plan developed by the state of Rhode Island to guide actions and investments in making the state more resilient to various hazards and stresses. So a community that is informed and prepared are going to have a greater opportunity to rebound quickly from weather and climate-related events. And I know Nantucket is definitely a resilient community. I've had the pleasure of working here for 4 years, which was nice to see such a tight-knit community really come together in the face of climate change. So in order to become resilient, there are 3 buckets of actions that we need to take when we're dealing with coastal climate impacts. One of them is knowing your risk, what's being impacted, making a plan, maybe that's a business plan or it could be a statewide plan, and then taking action in that plan that it's giving you recommendations on how to adapt. So I'm going to focus on knowing your risks for right now and some of the resources that we use in Rhode Island and that we share with the different communities to help them kind of understand what is happening and then to make more changes. So one of those mapping tools that we utilize in trying to understand the risks that are happening in Rhode Island is storm tools. And this is a great visualization tool to map flooding from a 25, 50, or 100-year storm. Plus, you can add in the option of sea level rise. So you might have a 1% annual chance with a 5 feet sea level rise, and then it just gives you an idea of how much water with the sea level rise impact is in your area. So if you're in Newport, Rhode Island, or if you're in Jamestown, you can see how it's going to impact your home and where you're living with sea level rise and storms. So this is just another example. This is a 100-year storm. So what that means is a 1% annual chance of this type of storm happening, plus 5 feet of sea level rise. And that is just showing in Newport, how is this going to affect my property? So this gives at least homeowners and community members an idea of what they can expect based on these mapping tools. Another user-friendly mapping tool that we use at the local level is a program called MyCoast. There are several in the country. Is anyone familiar with the MyCoast program, aside from the Woods Hole group? And Vince? Okay, good. So we really utilize this in Rhode Island. It's, for those of you who don't know what MyCoast is, but it's a portal to collect and analyze pictures and data related to coastal impacts. So information is collected through this app to visualize the impact of these coastal hazards and to enhance awareness among decision makers and stakeholders. So with MyCoast, we can at least help bring, public to science, and they can take ownership of being citizen scientists or community scientists and really taking photos of the impacts that they're seeing. And these photographs are really helpful for affecting future management decisions. The MyCoast app is also associated with environmental data. So when you take a photo of, let's say, Easy Street flooding, it does pull in the tide data, the date, weather, etc. So you do have that data associated with the photograph. So these are just a couple examples that 2 individuals downloaded to the app. One is in Watch Hill and the other is in North Kingstown. And this is showing 1 feet above mean high water. And that just refers to the average height of the higher of the 2 high tides that occur during each tidal date. So say that again. It's the average of the high tides. So it matters because it just allows you to connect. Oh, this is what happened before. I'm sorry, you're gonna have to bear with the animations, so I'm gonna have to keep going back to several slides. Hold on. All right. You might have to bear with me. You might have to skip this one because it keeps going. All right, so, yep. Anyway, MyCoast it's an important piece I really enjoy working with volunteers and getting people to sign up on this app. So if you don't have MyCoast already, and you have a smartphone, you can download it on your phone, and you can just become a community scientist and help us really document changes that are happening around the island here on Nantucket, or if you're off island as well. For Rhode Island, we focus on king tide events and storm impacts. Another point I wanted to make for a monitoring tool is Coast Snap. So some of you may be familiar with that. Who knows, there may be some talks of doing that on Nantucket. But what this is a cradle station that you find a location, and you can just place your phone in this little white piece that's above that CoastSnap station. And people can come by and place their phone and take a photograph. And so you're getting consistent photos at the same location, and then upload it to the app on your smartphone. And then we can consistently seeing long-term trends of our changes in our coastline. So this is, again, a great way that the community can get involved to really look at the changes in our coastline and to help us document change as well. We have 3 stations in Rhode Island when we are looking to expand. So once you understand these risks by using these tools, you can start to make some plans. There are plans at many different levels, whether that be statewide. So for us, it was Resilient Rhody, which was our strategic plan and how the state could move forward with climate impacts. There's municipal plans, such as our hazard mitigation plan, which is required by FEMA. A climate justice plan, which focuses on hazards that the environmental justice communities are dealing with, as well as non-governmental, which is our Towards a Resilient Providence, which is our partnership with the Providence Resilience Partnership. So we work with a lot of NGOs as well. So once we have our plans, it's time to take some action. So what our role at the Coastal Resources Center does include a lot of outreach and education. It's providing technical assistance, it's helping develop tools, training and mentoring to a lot of different communities that need help and that request our help. And it's looking at how we can help them take action, whether that's retreating, accommodating, etc. So in sum, becoming more resilient to coastal climate impacts involves knowing your risk. Sorry that this seemed to have been cut off in my slide. Making a plan, so like I said, state, local, it could be your neighborhood business, and taking actions. I know during the rest of the conference they're talking about green infrastructure and some of the items that Nantucket is taking to become more resilient and showing how they're taking action. I know Leah has a great talk that is coming up to talk about what they have accomplished so far. So like our keynote speaker did say, sometimes we have these depressing facts, but it's like, what can you personally do? A lot of people feel overwhelmed, and I know in my previous role with water quality, a lot of questions were, what can I personally do? So this starts with just educating yourself, knowing the risk that's either to your home or to your community, and knowing the cost of taking action, and also knowing the cost of not doing anything. When you're making a plan, this can start with just your family. You can also come together with your community. I look out, again, example for Nantucket. It's a really tight-knit community, and they come together to really make changes and support legislation. And then finally, once you start with that, you can actually start to take action, whether that's a personal decision to upgrade your home or make it more safe, as well as whether you want to make adaptation changes or relocate, etc. So these are just some resources that I have up here. If you wanted to check out My Coast, you can either download the app or you can look at it on the web, as well as CoastSnap, some of our storm tools, and then a little bit more about our strategic plan. Thank you. I feel like I was on time for the first time in my life. Or quicker, I should say. Anyway.
Okay, well, you can find her at the break.
Okay, thank you.
Okay, our next presenter is John Ramsey. He's a principal coastal engineer at Sustainable Coastal Solutions. Over the past 30 years, he has served as project manager and/or principal investigator for beach nourishment and coastal structure designs, regional shoreline management plans, hydrodynamic and sediment transport evaluations, and environmental studies required for permitting of coastal projects. He is responsible for oversight of engineering services at Coastal Solutions. Yep, so right here, you can look at the slides here. And then I think there is okay.
I won't bother.
Okay.
How's that? Hi, thank you very much. So I'm going to be talking a little bit today about project-specific stuff. I mean, we've talked a lot about sea level rise and climate change, but I actually want to talk specifically about a project we've been working on in Chatham. A little bit different than some of the climate change things we've seen. A lot of what's going on in Chatham, whether we had climate change or not, would have happened anyways. It's kind of a cyclical pattern that it happens about every 150 years, where we have a breaching of the Nauset barrier system and then reformation of those barriers and migration. And so we're in the kind of that portion of the cycle where everybody gets very upset because we've had a lot of changes, and a lot of infrastructure obviously has been built since the last time we had the breach back in the late or the middle of the 1800s. So this is Crescent Beach. On the slide here, so this is the beach, the barrier beach is fronting Stage Harbor. For those of you familiar, it's basically at the elbow of Cape Cod. And Morris Island, I'll be talking about a little bit more, which is over on the east side, is more of a glacial feature that is a little bit more solid than the barrier beach system. So one of the things I want to point out, this system has been modified pretty significantly over the years. On the top right there, you see what the Army Corps did in the late 1960s. They were having a similar problem at that time. And so what they did, they had a lot of shoaling in the inlet, which was a bit further east, about a half mile further east than it is today. And what they did is they just dredged through the barrier beach, made a new inlet, put all the sand over to the east, and created what we call Crescent Beach today. Down on the bottom right, this is sort of what the cycle that we're going with now. And I kind of wish I did have a pointer. Oh, I'm afraid to touch anything. So we'll go from there. But on the bottom right is the more recent development we've seen. The first photo, and I hope you can see it in the scale that it's in. But in 2011, basically we had the barrier beach on the south end was attached to the shoreline. As we move forward to 2016, that barrier beach started breaking up because there's not enough sediment supply with the formation of the 1987 breach in the outer barrier, Nauset Beach. And then it completely fell apart in 2017, and we actually created an inlet right along the eastern side of Morris Island. And that inlet created quite a bit of erosion. We've had a lot increased flooding, but again, a lot of this not necessarily due to climate change, but just because the barrier beach broke down, and now more areas are exposed to additional flooding. So Crescent Beach, how did that come about? So now we've all of a sudden induced all of this additional water coming into Nantucket Sound. And the currents were rushing right along the shoreline. And so what we've seen on average is somewhere around 18 to 20 feet of erosion per year. So this is jumping back very rapidly, and that's just since 2017. And this beach had been stable from the time the Army Corps built it, basically all the way up through 2017. And so in the bottom picture there, you see what that rapid erosion looks like. It basically creates a very abrupt dune cleaved off as the beach is moving backwards very quickly. So one of the things what we're seeing also with all that beach being eroded away is that material is obviously going somewhere. So the sand is conserved. So on the bottom left there, one of the things you see is the shoals coming along Crescent Beach, and you see the sand moving basically towards you in the picture. So it's moving from east to west along that shoreline. And so one of the things to point out there, that's the dredge working to reopen the channel. If you see where the channel, you can see the outer part there was completely shoaled in, and that dredge has basically been working pretty much constantly every time we have shoaling every winter. And that is, they're removing somewhere on the order of 50 to 80,000 cubic yards per year. So this is creating a serious problem for really one of the harbors of safe refuge on the Cape, and very important because obviously with all that barrier breakup, the area of Pleasant Bay and Chatham Harbor is becoming less safe for navigation. So this is really a very critical harbor to keep open. So one of the things we also know is because of this cyclical nature over the next several decades, one of the things we're going to see is that barrier beach on the outer shore, or out of the shoreline, the east side, is going to continue to migrate. And we expect the inlet that we were talking about, that Fool's Cut that opened in 2017, to actually fill back in, which is great. So anything that we need to do as far as stabilizing the channel in the Stage Harbor system is really just a temporary fix. We don't need the permanent coastal fix, the big revetments, the big groins, but what we do need to deal with is just this next approximately 20 to 25 years to make sure that we're dealing with things. By 2070, we expect that whole barrier beach system to be completely reformed in this area, and we shouldn't have a problem again for, again, until that cycle repeats in the next 100 plus years. So I don't want to go into detailed modeling because I could bore you guys to death with equations and all that stuff. But one of the things that we do is quite a bit of numerical modeling to make sure that we have a good handle on what's happening here. Very site-specific modeling. But one thing I want to point out was the tide curves up on the top there. One of the things you see with those tide curves, on the bottom is the tide that's in the Atlantic Ocean on the east side. On the top is the tide that's in Nantucket Sound. That's one of the things you see. There's a huge difference between the tides in the ocean versus the tides in Nantucket Sound, and that's what generates a lot of the rips and tidal currents we all see in Nantucket Sound over time, is that the ocean on one side is very different from the tide going on the other side. So one of the things that happens in this case, because of that, the currents primarily derive sediment and everything else from the ocean into Nantucket Sound, and that's why the system reacts the way it does. So we went through this whole modeling process of not only determining how the waves and tides react, but also how sediment moves in order to come up with a solution for this problem. And so this is a quick example. This is maximum tides, what I call ebb currents, which is basically when it's ebbing, going back out into the ocean. You see the tides, and then the length of the arrows is the actual magnitude of the currents. You see that magnitude of currents is actually relatively low compared to the other figure when we have water flowing in from the ocean into Nantucket Sound. And why that's important is basically if the tide currents are stronger, they're going to carry more sediment, but in this case it's actually a little bit different in that the currents when it's ebbing actually aren't strong enough to pick up sand. But when it's flooding, it has the ability to completely pick up sand and carry it along. And that's why we're not only having erosion along the shoreline, but we're also having all that material move into the Stage Harbor entrance channel. So we looked at a bunch of alternatives. That's sort of what we do as engineers. So this is kind of that next phase, is that planning phase as opposed to the implementation. But we do want to see what this would do as far as various alternatives. One is a no action, which I'll talk about. We also looked at reorienting the entrance channel, which really didn't work out to be anything other than delaying the shoaling. But the only problem with that is it really doesn't fix the erosion problem at Crescent Beach. Inlet relocation, we could jump the inlet further west, but the environmental impacts associated with that would be pretty dramatic to salt marsh, et cetera, as well as the estuarine system of the whole Stage Harbor system. And then we looked at various flow control structures. I will talk about that in some detail, and then also these temporary structures with nourishment as an additional alternative. So one of the things I want to talk about a little bit is this no action alternative, and this is alternative one. So for any of you that visit this part of the Cape, the Monomoy National Wildlife Refuge headquarters is on Morris Island. This is on the east face and northeast face of that island. And this on the upper picture, this is a picture from a couple years ago. There's the weather station there. That weather station is now gone. The area the weather station was sitting on is now gone. That whole area is eroding at a tremendous rate, and this is kind of that no action alternative. The National Wildlife Refuge has decided not to do anything about it, and while that's fine for them, the properties to the south are having horrific erosion problems and having a serious ability to try to protect their homes because the Wildlife Refuge has let this go. And keep in mind, this is just a temporary time period. If they had chosen to protect it for a couple decades, and I'm not suggesting armoring it, but protecting it some other way, that erosion likely would be mitigated in a couple decades from now. So this just gives you an idea of what some of the modeling results look like, the different color shading. That blue on the shadings, these are change plots, so that blue is an area that would be basically less accretion, especially in the channel there. You see the blue, the red over by the channel, less accretion, and then the blue elevation is some scour. So this is just kind of what we're seeing as far as what happens here in the system, and this is sort of what we're using to base all of our alternatives analysis on, this type of modeling. So going to these alternatives, one of the things we looked at is a variety of flow control structures. I can say that we looked at hundreds of alternatives, which we did, in trying to come up with some of the ideas that might work here. What we really want to try to do here was originally try to deflect the currents away from the shoreline so Crescent Beach wouldn't erode as rapidly, so we can protect that, and understanding that these are a temporary concept. Realizing that wasn't something that was working very well without other adverse impacts, one of the things we basically tried to do then was really just slow down the currents, and that's what you're seeing here, protecting the shoreline with what we call a temporary groin, but at the same time having these vein structures that are really intended just to slow down the currents further to the east and allow that beach to stabilize itself, keep the material from migrating into the channel. And again, from a cost-effective standpoint, you're looking at 50 to 80,000 cubic yards per year flowing into that channel and filling it up. Basically you're looking at several $1 million every time the town has to clean that out. The Army Corps does come in on occasion, but we got to the point in that channel where the marker buoys were actually out of the water, sitting on dry sand. And so we had to get a special dredge in there just to get the buoys back in the water before the Army Corps could come in and do their project. So it was a challenging type thing, but these are the kind of the various structures we looked at in this kind of just that optimization process that we went through to look at these structures. And so I'm just going to talk about two of the alternatives very briefly, just to give you an idea of how we go through the process of refining our results. And this is design B, and that's the one that would be further to the west. One of the things I point out, there's a little thin black line. You see that's actually the Monomoy National Wildlife Refuge boundary, which does create some, and I hate to get into the regulatory side, but create some regulatory hurdles, because if you're in the wildlife refuge, the concept of even a temporary structure would likely be prohibited. The fascinating thing about that is that the Army Corps actually built their project in the 1960s, well after the wildlife refuge was formed, and it goes right through the wildlife refuge, but nobody seemed to notice at the time. Very entertaining, but it's the federal government working with the federal government. So, I'm working for the town, so it's a little bit different. One of the things we do want to do, if we can, is to stay out of the wildlife refuge. But on the bottom there, one of the things you do see is, again, that change plot. The blue is less accretion. Again, you see less accretion coming into the channel. When you go further to the east, that blue is actually representative, as opposed to less accretion, it's actually scour, and the red is accretion. So one of the things you see is red. The red accretion is along the beach system, which is what we want. We want the sand to retain itself along Crescent Beach. And then alternative F, which actually stays out of the National Wildlife Refuge, which is a preferred on my concept, but not prohibitive. But one of the things you notice there, that actually works a bit better. It does the same ability to stop the accretion, or at least slow down the accretion coming into the channel, but it also creates quite a bit more accretion along the beach area. So that's something that we really want to target and do a good job on. So that is looking a little bit better. I'm looking at it a different way, and again, I promise not to talk about modeling because it drives everybody crazy. But one of the things that we did is we looked at basically the cumulative sediment transport that happens for each of these alternatives. If we look at these two lines, so the first line is the north line, and then which is that observation line A, and the second one is observation line A and B together. So an observation line A, that's just the difference between the base condition and basically the two alternatives. And so observation line A, we see that right now we have a lot of, the blue line is the existing conditions. We have a lot of sediment transport going into the channel. But the other two alternatives pretty much do the same thing. But if we look for the whole area, because we also want to look at what's going to be happening in the outer channel as well, again, there's a lot of accretion obviously coming the way it is now. We've got about a 30% drop-off by that option B, but we get about 60% drop-off by option F. And that really, if you think about it, having to dredge on the order of 10,000 cubic yards per year rather than 50,000 cubic yards per year is huge. And they might be able to leave it for a few years without dredging it and save that cost. So that's sort of what we're looking at. The one thing I do want to talk about is the concept of beach nourishment as well. I'm a firm believer in beach nourishment in the sense that if it is something that can be used to mitigate some of the erosion problems we have. It has to be done in the right way, in the right place. In this case, one of the things we're trying to do is really get back to that situation we were pre-2017. Keep in mind this barrier beach was eroding very, very rapidly. And because of that, we're only about 5 years away from it actually breaching and creating a new inlet into Stage Harbor, which will have all sorts of adverse impacts. So one of the things we really want to make sure that we do is not just stabilize and prevent that material from moving down coast, but we also want to make sure that we're restoring the beach at the same time. And by slowing down the currents, we can actually stabilize that beach in that position. One thing I do want to point out is that these structures, as ugly as they're going to be if they ever get put in, are temporary. So they're basically a sheet pile that you would put in just to block the flow over that time period. And through the permitting process, which we are initiating now with MIPA, the whole concept is that these will have to be taken out. And when I should point out that old Army Corps structure when they built their barrier beach, in order to protect their barrier beach, they actually put out a wood structure. And unfortunately, they didn't remove it all. So people always talk about the piles that are still out there. But this is going to be required to be removed. And so again, temporary in nature. The other point, obviously I pointed out already that we're planning on keeping this outside of the National Wildlife, or the Monomoy Wildlife Refuge, which really is a plus from that standpoint. We're still going to have to work with the Army Corps because we are certainly impacting their project in some way. Basically, we're doing their job for them, but I do not want to do any Army Corps bashing. Not that we would ever do that. So this is what the project would look like. This is the subaerial beach in the tan, I guess it's tan. And then the footprint of the beach nourishment is in the blue. So you get an idea of the level of environmental impact we're looking at. This beach nourishment project, we talk about beach nourishment projects. We've been involved with projects out of state that are millions of cubic yards. It's very odd in Massachusetts to see projects that are more than a few thousand yards. This is on the higher side for Massachusetts. It's about 84,000 yards, but it's going to stabilize Crescent Beach for the foreseeable future. And certainly they have enough material by dredging out of the Stage Harbor entrance channel to make that work. So I just want to go through some quick aerials. This yellow line, in this case, is the National Wildlife Refuge boundary, just to give you an idea, and you see the footprint of what we're proposing. But this is 2018, so it's right shortly after that breach the opened. Just to give you an idea as we march along, keep an eye on the barrier beach system that's off to the right in the photo. So one of the things you'll see it migrating back and migrating back again. And finally, in this photo, it's here. It's not going to attach to the shoreline anytime in the near future, but we do anticipate, with enough sand coming down on the further out barrier beach, that eventually that barrier will join, and we expect that to happen in the next 15 to 20 years. And then again, this project will no longer be needed. So this is what the preferred alternative looks like. I just wanted to put it in perspective to what the Army Corps had done, so you get an idea of that footprint of the Army Corps where they moved the inlet. And again, very high erosion rates in this area, so we're very concerned in the next 5 years or so that Crescent Beach will breach. So this is, the idea is that, again, while this is a structural project, it is the eventual concept of trying to do as little harm as possible and trying to work with the system we have and understanding this is going to be a temporary fix. The other thing I'd like to point out, within the regulatory process, we're looking at a placement zone as this initial placement when we place where we're proposing it. But because of the unknown of the shifting shoals, one of the things we're concerned about is the probability that things will not happen exactly the way we want. I think there was an earlier allusion to the fact that trying to predict the future is a little hard. So one of the things we're doing is making sure that we have the ability to move these structures if they need to be, but again, only there for a temporary basis. And so with that, I'll open it up to questions. I hope I was on time and not too fast. I can repeat it. Yeah, go ahead.
I can talk about it. I'm curious if you're doing mitigation work. Are you doing any kind of like sand sediment transportation studies, or doing any kind of sand budgeting to figure out how the different alternatives play out? Thank you.
Sure. So as far as the question was about whether we're looking at sediment transport or sand transport studies to evaluate the different alternatives, basically, right? So yes. So that modeling that I showed, again, I didn't want to go into the detail of the modeling, but all that's done. So we looked at not necessarily sediment budget in the case of the inlet, because the inlet sediment budget is changing so rapidly because of the new system. But what we did look at is sediment transport associated with each of the alternatives and which ones would be more or less impactful and more or less achieve the project goals. Does that answer your question?
Yeah, I was also wondering, do you have a baseline transportation study that you used like before, if anything?
Correct. So what you saw, those blue curves on with the original stuff, so the question was whether we had a baseline study. We always base everything on existing conditions. So we have a baseline study of what the sediment transport rate is before we start, and then everything that we're doing is trying to reduce that sediment transport rate. So yes, that baseline was the blue lines that I showed on the plot. If I didn't make that clear, I probably went kind of fast. Sorry. Okay.
Okay, the last presenter for this topic is Chris Reed. He is a landscape architect and founding director of Stoss Landscape Urbanism, which participated with the town and Arcadis on the Coastal Resilience Plan here on Nantucket. Chris is recognized internationally as a leading voice in the transformation of landscapes and cities, and was a recipient of the 2012 Cooper Hewitt National Design Award in Landscape Architecture. He is also a professor of landscape architecture at the Harvard University Graduate School of Design. His commitment to teaching is not only a way to develop the next generation of landscape architects, but also keeps Stoss on a constant quest for new ways of seeing, thinking, and doing.
Good morning. Come on, you can do better than that. Good morning. Good morning. There you go. Great to be here. Thanks for having me. It's really great to share, great to learn from all of you, and it's been a pretty rich morning so far. As Leah said, I'm a designer, and what I want to talk today is about how we design within these dynamic environments as we're taking on climate change and a whole series of other issues that are at stake. I'm from Boston, where, like here in Nantucket, we are experiencing climate change on a very regular basis. This is king tide, typical king tide on Long Wharf in Boston. Long Wharf is the oldest pier in Boston, right at the heart of the financial district, and this condition happens quite regularly. It's also happening in the neighborhoods. This is a supermarket shopping lot, a supermarket parking lot in the neighborhood of East Boston. And you can see here, it's not just affecting us, but it's affecting some of the other creatures that we inhabit the world with as well. The work we do sometimes is in very intensely developed areas like this. This is East Boston, where existing neighborhoods are thriving. Sea level rise is threatening these neighborhoods. It's also threatening critical infrastructure. This is right near Logan Airport. And we work with towns and municipalities and incredible teams of engineers and scientists and ecologists to begin to devise adaptation strategies, sometimes, in this case, creating a string of parks and green infrastructure along the edge of the coast in order to protect inland resources and people and create new opportunities for interaction with the harbor. In other cases, though, we're involved with towns on retreat strategies. Over 10 years ago, the folks in Dennis voted to purchase a piece of waterfront property that was devoted to a commercial building with a restaurant. Those buildings were taken away, and this site was converted to open parkland. Our design not only takes into account restoration of native ecologies, but allows water to move inland gradually over time. We're providing public access, but we're creating lowland and upland conditions that really raise the quality of the environment, but also give, over time, places for water to go. So this whole idea of interactions with the environment, allowing people to experience places like this, and in some cases, removing permanent human activity is part of the work that we're doing. It's also part of the work that we did at the Coastal Resilience Plan here in Nantucket, combinations of retreat and adaptation, but also opportunities like here along Pulpus Road to increase quality of habitat. The underwater structures that you're seeing there not only help to attenuate waves, but create new habitat beneath the surface of the water. And the idea of allowing people to experience these environments, really important in proposing an elevated multi-use trail here, not up against where the vehicular traffic is, but actually out in places that allow people to experience nature. So often the work we're doing really embraces the dynamic living environments around us, even sometimes in very, very tight spaces. This is an animation that is not running. Let's see. The idea that we might have floating boardwalks that rise and fall with the tides, but also a landscape that's stacked and terraced so that as sea level rises, the landscape is there to anticipate that, and the landscape itself can also protect critical structures, in this case the New England Aquarium, from the impact of storm surge, even after sea level has risen. So how is it that we really integrate educational landscapes and functioning ecosystems, even in the tightest of urban sites? So I want to show you a couple projects that really demonstrate these principles in different ways. I took the topic of around the Cape and Islands quite liberally. This is Milwaukee, Wisconsin. Just wanted to show you a few places from around the country, really, that we've been doing work. Very small site on the port of Milwaukee, a highly impacted site, formerly industrialized. Here, the city chose not to build here, and really asked us to design an open space that would deal with not only opportunities to get people to the water, but various forms of flooding that this city was experiencing. This little site is terraced, so you can get down and closer to the water, but it functions in pretty critical ways. First and foremost, we break the surface so that storm water can actually infiltrate the ground in multiple places. Rainfall and overland flow will flow to the lower area of the site, which allowed us to replant a native marsh, increasing the quality of that environment. And lastly, we cut slots in the old bulkhead wall so that as the river rose, water could invade this area of the landscape as well, giving water back its space within the urban environment. What does this produce? It produces some pretty beautiful places for people. Incredible array of plant material here, which changes quite dramatically over the seasons, something that's really quite evident to people. This floods quite regularly with the increasing intensity and frequency of storms. And so thinking about ways in which sites like this can deal with stormwater is as much as important as the ways in which they can deal with flooding from rivers and from the coast as well. It also integrates other elements as well, particularly a grove of trees, which is important in terms of layering in biodiversity, but also in reducing the ambient temperature within this environment. So trees in particular help cool urban places like this. Overall, making this much more rich habitat for both people and creatures around us. A second project in Ann Arbor that deals with stormwater specifically. So often we're asked, if you build coastal defense systems, what happens with the stormwater falling inside of that? How is it that it gets out? And this project takes on some of those questions in slightly different ways. This is in Ann Arbor, Michigan, admittedly not a coastal site at all. It's part of a 4-acre quadrangle at the University of Michigan's North Campus. And so the campus itself has to deal with a lot of requirements in terms of circulation, student gathering, et cetera. You can see this is not a typical campus quad. We're layering in different kind of plant materials to increase biodiversity. We planted over 250 trees on 4 acres of land, again for biodiversity and cooling purposes, and you can see the kind of spatial layering and lushness that results from that. More importantly, though, are the little illuminated gardens at the bottom left of this image. Part of the requirement here was to detain 95% of the stormwater, allow it to infiltrate the ground. But this is a very difficult site with clay soils that don't allow water to penetrate the ground too quickly. So we had to create 5 pretty big retention basins to hold that water over time. We planted them with a lot of plant material to create real gardens, but also created an illuminated effect here. You can see these lighted rods here that actually react to the water that's entering the stormwater gardens. So the more it rains, the more the lights flicker. The more miserable it is out, the more beautiful the experience. And so we're looking for ways there to bring sustainability to life and really make connections to the environment, in this case through simple technology to people. A few more images of that. One of the biggest projects, one of the most challenging projects we're currently involved with is Moakley Park, 90 acres on Boston's harborfront, a primary flood path for storm surge and sea level rise. In fact, it's one of a number of primary flood paths that will flood neighborhoods immediately around Moakley Park, as well as critical infrastructure not so far away. This project's quite complex in a lot of ways. We're trying to solve a lot of problems, dealing with roadways and access, dealing with program and who uses the park. But most importantly, this is kind of the flood impact that's projected for 2070, not only again within the park, but on both public housing developments and existing neighborhoods very much nearby. And so the park institutes a series of integrated flood control methods that keeps some of the water at bay, but creates some really wonderful landscape environments, and also deals on the inland side with stormwater flooding through the design of a series of gardens. All in all, making an underutilized park that's quite vulnerable on the waterfront into a real destination park and a model for how you do resilient parks of the 21st century. There's a lot of programming and activity. We use a combination of gray and green infrastructure here because of very high groundwater tables that will continue to rise over time. We're embedding flood control measures into the landscape. You can see how outdoor performance and event spaces can act as flood control during a future storm. And we're using the opportunity to really create some amazing new wonderful environments, a coastal park that ultimately is completely floodable up until this line, which is a bermed flood wall fully embedded within that landscape. This project, though, is so much about the way in which we've talked to people and fully engaged people. Whenever you're doing public projects, and I know many of you who work in cities and towns are doing this yourself, how is it that you really share the knowledge that you have, identify some of the threats, but also get some real buy-in from the people who are most vulnerable? At Moakley, we used a whole range of different kinds of engagement activities for different age groups. Some of those were virtual, some of them were in person, some of them were in meetings, some of them were on the site. As of 2 years ago, we had 22,000 individual engagements with people, generating a lot of feedback, generating a lot of impact. These charts really talk about some of the issues that residents and visitors have brought to us. Most importantly, though, is showing people how that feedback is responded to in the design work. And so we spend a lot of time on drawings like this, saying, this is what you told us, this is how the park has responded. This is how the design responds. And so that very close dialogue really builds constituencies and ultimately builds support for the projects going forward. Just want to quickly show you something in Galveston. Galveston, a lot of folks in Galveston refer to Galveston, Texas as an island off the coast of Texas, not necessarily part of it. Galveston's been battered by hurricanes. In fact, in the early 20th century, they took their entire downtown and raised it 12 feet in response to flooding and threats. And they're considering doing other radical measures as well. We worked with them to look at inland flooding, stormwater flooding, and a series of, great. So a series of sponge parks that deal with stormwater, a series of conservation measures, actually, that hold land in order to allow water to flow through rather than be inhibited. But most importantly, a series of engagement sessions around the redesign of the seawall here in ways to make it more socially and ecologically rich. This activity in particular was very successful. Build your own seawall. We developed a series of parts. Residents could sort of combine those in different ways with the idea that this was a participatory design activity that certainly accomplished the goals of protecting parts of that community from sea level rise and the impact of storms, but also, again, allowed people to have a direct impact on the future design and programming of their city. And so a whole series of different kinds of techniques that we're using within the public realm. Lots at stake here for us, for the creatures around us. A lot of questions are raised. We're dealing with a lot of those today. Hopefully, we'll see a bright future. Thanks. Yep.
And one of the challenges is the community said they want to be able to touch the water. Do you have any ideas for how to best do that, or any of those projects maybe showed that in an urban environment?
Yeah, sure. This woman works for the trustees of reservations in East Boston, where there's a beautiful proposal for Pierce Park. And one of the conversations they've been having with residents is how to get down and actually touch the water, particularly in a highly urbanized area. Yeah, I think the touching, right, really brings it home to people. It's challenging in urban environments like that. At the New England Aquarium, the idea wasn't quite that you could really touch the water, but the idea of these floating walkways that would get you down, at least closer to the water, and engage with it. We also designed on those pilings mussel gardens that would be revealed during low tide, so there was a different kind of experience there. I think those kinds of opportunities are really important. We're dealing with a steep site in Edmonton, Alberta, that's actually called Touch the Water. That's the name of the project. And it's a challenging set of sites. So how is it that we can bring walkways closer, give people views out, and occasionally where it's safe, to have scrambles to get down there? I think in that sense, people are really looking for that moment to be, very elemental, right? And really touch and participate in that environment around it. Sure. Thank you.
All righty, thank you everybody. So we're going to start now with topic 2. Topic 2 is coastal resilience on Nantucket, a subject that I have particularly enjoyed for many years. The first speaker is Leah Hill, who's going to talk about something that I have worked on, that I have treated as my own, and now have passed off. Leah is our coastal resilience coordinator with the town of Nantucket. Leah was hired and started her position in February. Prior to this, she was the town's assistant biologist for 9 years, where she grew shellfish for restoration and enhancement, planned and implemented the town's first oyster restoration project, and established the town's first shellfish recycling program. Her love for the island started at an early age, and she is excited to continue implementing the town's coastal resilience plan so that Nantucket can become a more resilient to climate change. In her spare time, you can find her in, on, or under, or around the water with her family and dogs and friends. Let's hear it for Leah, please.
All right, thank you all. Today I'm going to give an update about where we are with the town's coastal resilience plan about 1.5 years after it was adopted. The plan's mission it draws on the cherished built and natural heritage of Nantucket to create a community-supported roadmap to implementation for a series of layered flood control and adaptation approaches that lessen the loss from storm surges and help the community adapt to rising seas and eroding coastlines. In coordination with other ongoing adaptation and sustainability initiatives, the plan addresses the whole island and county while respecting the unique characteristics of each neighborhood. Driven by the inclusive and equitable engagement for all, the plan aspires to create social, environmental, and economic benefits and value to everyone who will share in Nantucket's future. The 5 goals of the plan is to build coastal resilience and reduce coastal risks from flooding and erosion, enhance safe access to, from, and across the island, promote the health of natural ecosystems, generate waterfront public space, connectivity, and safety. And the 5th is to develop implementable strategies that will result in reduction of flood and erosion risks. Now, this plan had over 100 stakeholders, ranging from town departments to nonprofits to visitors, the community. And at 2 of the public meetings, there were over 100 participants each. The plan also incorporates a risk assessment that uses the high projections of sea level rise for Nantucket and also the Massachusetts Coastal Flood Risk Model. It also has a guide for property owners to be able to make their homes more resilient. So today I'll be talking about 40 recommendations that are within the plan, and they should be implemented by 2050, but most of them should be implemented in the next 10 to 15 years. So how are these strategies, how did they come up? They used a bunch of different categories, and the first is Vision for a Resilient Nantucket. So this plan really built upon 7 prior plans that the town had. It used community engagement, and then it refined that with the risks that are seen. The next is coastal risks. So coastal risks are, the potential for coastal and high tide flooding, coastal erosion, groundwater table rise to cause negative impacts to infrastructure and the community, and how are we going to adapt to these as sea level rises. This used the prior plans, the risk analysis, focus areas, which are downtown and Brant Point, Sconset, Nantucket, the South Shore, Pulpus, Nantucket Harbor, and Cotuit, and then the jetties to Eel Point. The coastal risks, like I mentioned, that we see on Nantucket are erosion, groundwater table rise, coastal flooding, and high tide flooding. And these are all pictures from the island. In the risk assessment, over 2,000 structures are at risk through 2070. 84% of at-risk buildings are residential. 9% are commercial, and 49% of at-risk buildings are historic. 9% of at-risk buildings are tourism related. So this map depicts calculated damages and losses by 2070. The pink dots, each dot represents $50 million. So you can see that's pretty much our whole downtown. And then the other colors vary in cost. The green is about $2.5 million. So without, the damages and losses to 2070 was calculated to be $3.4 billion. Talking about billion, not millions. This is a huge number. And $108 million of that is expected at 34 community facilities. All recommendations, if we are to implement them, will cost between $830 million and $900 million, but the take home here is that if we don't do anything, the losses and damages far exceed the plan's implementation. The next is the Coastal Resilience Toolkit. This is based on expertise and knowledge of an area, refined with risk and engagement into actions, and refined through strategy development. The Coastal Resilience Toolkit catalogs a wide range of resilience approaches appropriate for Nantucket. It's broken into 3 approaches. So the first is protect, just over here on the left. This is a picture out in Dionis. One house has a rock revetment, the other one has a bulkhead. The next approach is adapt, so living with the rising seas. This is the middle picture, is a new house on Easton Street that has been raised or elevated outside of the flood zone. And then the third is relocate or retreat. The picture on the far right is a house being moved back on its property out in Cisco, away from the eroding coastline. All recommendations follow these 3 categories: protect, adapt, or relocate, and then they're broken down into structural to non-structural. And then all of these were evaluated. So the evaluation criteria touched on 5 topics. Is it the effectiveness, the feasibility, does it have ecological and public health benefits, equity and quality of life benefits, and value creation. So all of that came about to have these strategies or recommendations, and the strategies are realized through development of project alternatives, refinement through engagement and technical analysis, and then project prioritization and implementation. All right, now I get into the good stuff. So the next slides are all projects that are either underway or complete within the town's CRP. The first one is updates to wetland ordinance and regulations. This is a high priority within the plan. It used a lot of ideas generated from the CRP. A couple examples that you can find within the proposed regulations are added definitions of coastal resilience, coastal risk areas, high tide flooding, and also when rebuilding a bulkhead or groin, the applicant must examine using a living shoreline or moving the threatened building instead of rebuilding the bulkhead. A second example is in areas of eroding coastal bank. The distance from all new structures to the coastal bank should be at least 20 times the average annual erosion rate, or 100 feet, whichever is greater. A third proposed example is the no disturb buffer zones and marshes to be extended from 25 feet to 50 feet. So this recommendation is underway by the Natural Resources Department, the Conservation Commission, Town Council, and also the public. So there will be many more public hearings to come if anybody wants to give their opinion about the proposed regulations. The next one is the Coastal Resilience and Sustainability Interdepartmental Working Group. This recommendation is a governance approach to encourage interdepartmental collaboration and coordination on issues related to coastal resilience and sustainability. It's a high priority, and it was implemented in 2022 by the Natural Resources Department. This group includes town administration, natural resources, plus, and the DPW. And we're currently working on a sustainability and resilience dashboard for the town's website. The Coastal Resilience and Sustainability Program, again, another high priority. The recommendation is a governance approach to establish a formal program with necessary resources for managing coastal resilience and sustainability projects and programs across the island. It was implemented in 2022 by the Natural Resources Department. I'm sorry, that did not come up right. That is the wrong text. But this is a program that was implemented in 2022 and to have funding for projects for sustainability and coastal resilience. And the program includes Vince and myself. Okay, the Pulbus Road raising, culvert expansion, and wave attenuation at Sacajah Pond. This is a very long name for the project, but it is in 3 phases. So the first phase is underway, and I will say that all phases, the town is working in collaboration with Mass Audubon. They own property that is adjacent, and that would be affected by this project. So the first phase is to create a nearshore oyster reef using reef balls, which are eco-friendly concrete structures here, and they provide habitat for oysters and fish. They also act as wave attenuators. So this is a project in Connecticut, and you can see the waves are actually crashing on the reef balls. This project is funded by a SNEP grant, and it will be implemented by 2024. The second phase, which is also underway, is creating a living shoreline between the pond and Pulpus Road. So to give a little background, in 2018, the Pulpus Road was closed to erosion during a winter storm, and then there was an emergency quick fix that has jersey barriers between the pond and the road. So this is to remove that jersey barrier and install a living shoreline. And the living shoreline can, promote resilience. So it's a natural barrier to waves. It can also help with pond water quality by filtering runoff from the road that go into the pond. And this is slated to be implemented in 2025 or 2026. The third phase of the project is a priority 2 within the CRP, and it's slated for 2035. The proposition is to raise the road and replace the 3 culverts under it with either a bridge or larger culverts to connect the pond and the wetlands and maintain emergency access while restoring the ecology. It's estimated to cost between $40 and $50 million, with up to $11 million in benefits. And the nice thing about a living shoreline is that it can be adaptable and it can grow in height as the road raises as well. The next is the Shoreline Change Monitoring Program. This was a priority 2, and the recommendation is planning to upgrade to mobile technology and other tools to encourage the community members in the process of monitoring shoreline changes across the island. It uses methods from Massachusetts Coastal Zone Management for shoreline change. So basically it's transects and stakes at 20-foot intervals, and then we measure from the nearest stake to the edge of the coastal bank. This has been underway since 2021 by the Natural Resources Coastal Resources Technician, Morgan Sale. It was actually the first project implemented from the plan because we could easily do it with the natural resources employees. The highest rates that we have seen from 2021 to 2023 are at 2 locations. One is at the sewer beds. It's lost 50 feet in those 2 years. The other one is at Nantucket Public Beach, and it's lost 47 feet from 2021 to 2023. The sediment sourcing and transport study and dredge plan. So this is actually 2 plans into one. It was a high priority in the CRP, and it started in 2023 by the Natural Resources and will take about 18 months to complete. The study areas are located in pink, so it incorporates the 3 harbors and a little bit outside of Nantucket Harbor. The main goal is to develop understanding of stable and unstable sediment, sensitive ecological areas, and shoals and barriers to navigation. That information will then develop a needs-based plan for dredging, which will include appropriate uses of dredge sand, where to store it, sail, beach nourishment, and coastal resilience projects that it could be used for. The Stormwater Bylaws Assessment and Surface Water and Groundwater Protection Regulations. This is a priority 3. It's a planning step to conduct an assessment of existing bylaws and update stormwater management bylaw to encourage BMPs that address water quality and quantity issues. So these programs are intended to positively impact the controllable load to the town's stormwater system, surface water bodies, protect public and private water supply, protect groundwater resources, and increase overall resilience to storms and flooding events by preventing illicit discharges and connections to the town's stormwater system, regulating discharges from swimming pools, regulating land disturbance, development, or construction, and regulating generally the discharge of water to surface water bodies island-wide. This is completed by the Sewer Department. It was adopted by the Select Board back in March of 2023. The next is updating locally adopted sea level rise scenarios and best available flood hazard data. This is a high priority, and the recommendation is to adopt sea level rise scenarios provided by the Commonwealth of Massachusetts and the MCFRM as the best available local flood hazard data. In 2022, the Select Board accepted recommendations from the Coastal Resilience Advisory Committee to incorporate sea level rise projections and decision-making processes. And since then, new models and updates have been released, so that recommendation will then be updated, and it will include NOAA's high scenario for Nantucket, which in 2100 is 6.6 feet of sea level rise. It just needs to be brought before the Select Board, which I think is going to happen in July. And right now, the MCFRM is on the town GIS, so you can access it there. The next is Department of Public Works Facility and Landfill Resilience. This is a high priority. The recommendation is a building scale resilience and operational resilience planning to reduce risk of damage and limit disruption to core operations at the facilities. The first step in this recommendation is a site-specific study to determine the appropriate risk mitigation approaches for the facility. So this picture is from 2030 of Massachusetts Coastal Flood Risk Model. The facility is over here. Green and red are low probability of flooding. Purple and blues are higher probabilities of flooding, and you can see that the facility is quite close to that purple and blue area. And as sea level rises, it will increase as well, because Long Pond is a tidal pond. This project is underway at a higher planning level to see where the best available spot is, or if the current location should be adapted. The next is the Baxter Road Alternative Assessment. This is a priority 2. The recommendation is planning for an implementation of road relocation, including acquisition of easements, access and maintenance agreements, finalization of road alignment, and development of final designs for construction. Due to high erosion rates on Sconset Bluff, and Baxter Road is at risk. At some spots, there's only between 50 and 60 feet from the edge of the road to the edge of the coastal bank. This has been underway by the town of Nantucket and property owners since 2021, and it's due to be complete in 2024. The route has been selected, and we're currently designing the route and getting planning applications together. The Tom Nevers Field Erosion Mitigation Pilot Project, it's a high priority. The pilot program of dune restoration and sand fencing and beach nourishment, monitoring program to evaluate how well the pilot project performs to inform future investment in Tom Nevers Park, as well as erosion management elsewhere on the island. This is underway since 2022 by the Parks and Recreation Department. This picture is a schematic of the master plan. So it's moving the fields further away from the coastal bank. These colorful lines are projected erosion rates. So the red is for 2050 and the yellow is for 2100. Excuse me, I'm recovering from a cold. The last project that I'm going to talk about is Sheep's Pond Relocation Study. This is a priority 2, but quickly became a priority 1. Overnight in 2021, the road was washed out. We lost about 10 feet of coastal bank and 6 feet of the road. So the recommendation was to have a planning step to study where the road should be relocated. So there's not a study going on, but the relocation efforts are actually underway by the town, the Nantucket Conservation Foundation, and private homeowners. and currently reviewing potential layouts for that location. So in summary, in the last year and a half since the CRP was adopted, there's been 3 projects complete, 9 projects underway, 10 in development, and 17 not started. So more than half of the projects are either in development, underway, or complete. And with that, thank you. I don't know if we have time for questions or not.
I'm just curious, with the Pulpus Road raising, you had a cost estimate and then a cost benefit, and I'm just wondering, what are the benefits that have a monetary value attached?
Yeah, so that's a great question. He's wondering what are the cost benefits that the Sacajapon Pulpus Road raising has. And so the main thing is emergency access, because that road is very close to the pond, and as sea level rises, groundwater rises as well, and so that road is actually, could be flooded quite frequently and also experience even more erosion. So that's one, and then all of the ecological benefits. So on the other side of the road kind of cuts through a wetlands, so on the other side to have the pond and the wetlands reunited. So that's just a couple. All right.
I'm a little confused with your high priority, third priority, second priority. So Washington Street, where the steamship, all the trucks are coming out onto, where is that priority?
So that's a priority 1. It's a highest priority. It's also a very, so I don't, are you talking about the Easy Street Road? Washington's. So actually Rachel will be presenting next about the Washington Street project that they're working on, that the land bank is, but we're advising with them, and we do have plans for Easy Street Basin as well, Easy Street Road, to hopefully raise that because it experiences flooding just like Washington Street does. All right, thank you.
Wonderful. Thank you very much, Leah. And to continue in the coast resilience in Nantucket, we're going to hear the next presentation, Coastal-Based Solutions in Concept and Practice, from Rachel. Rachel Freeman works for the Land Bank since about 2015 and is currently the Director of Environmental and Agriculture Resources. She has been involved in the natural science on Nantucket for about 20 years and still can't believe it has been that long. When not at work, she can be found happily enjoying the island's outdoor spaces, gardening, or walking her dogs with family and friends. Please welcome Rachel Freeman from the Land Bank.
Thank you, Vince. The title of my talk today is Nature-Based Solutions in Planning and Practice. And before I get going, I just want to acknowledge a couple people. I would like to let everyone know that this is a land bank project, but we're also working with the town on this project, as Leah just mentioned. And I'd also like to give a shout out to Claire Martin, who's in the audience, because this is co-funded by Remain, and they've been great partners on this project as well. So, just to get going here, I want to let you know that today I'm actually going to be focusing on a proposed resiliency design, and I'm really going to be delving into the modeling, which I know was described earlier as not that exciting. But it's been a fascinating process because we've really been able to look and verify the efficacy of our proposed design and assess the weaknesses of the project, which has been very enjoyable for me. Again, I work for the Land Bank, and so the Land Bank does things, it's a municipal program, right? And we focus on conservation, recreation, and agriculture. And we have a lot of public waterfront parks. Providing public access to the beach has been a major emphasis of the Land Bank for a number of years. And so what we're finding now is that we have opportunities to take the parks that we have that are on the waterfront and create things like green infrastructure that you've heard talked about today. We find that to be a really interesting idea because it's near term and flexible in it, and we can be adaptive in this whole process. As we've talked about, there's a lot of predictions, and we see the curves and we see the way things are going, but there's also still a lot of variability, and nobody's exactly sure how things are going to turn out. And so for now, we feel like it's really important to stay flexible in our design approach. This park, actually on the right, let's see, this thing? No. Do I get instructions? Was there a pointer somewhere? Anyways, on the right-hand side is our Easy Street Park. That was shown earlier in one of the, actually in the keynote, in the keynote presentation today. And one of the things that we're focusing on, which you've also, I feel like everyone set me up perfectly today, frankly, so thank you very much. One of the things that we're really focusing on is providing floodable public open spaces. These spaces are areas that are environmentally friendly, ecologically sound, can be areas of recreation, but also can flood when we have storm events or daily high tide flooding or intense precipitation events. This is the project that I'm going to focus in on today, and we've been working with the WHOI group and SCAPE on this project, and goodness. And basically what we're doing is we're trying to create what we would call a resilient Washington Street. Washington Street is a super important transportation corridor. It's basically the way that the trucks access Mid-Island from downtown Nantucket. You get off of the Steamship Authority and you have to make it there somehow. Washington Street is the way to go. The land bank has been strategically purchasing parcels along Washington Street for a number of years now, and so the vast majority of the oceanside parcels are owned by the land bank. Also, a large amount of ownership is through the town as well. There's between 4 and 8 private parcels along the oceanside stretch. So what we started to do was we saw an opportunity to basically take a look at this site and see what it would look like if we went sort of the route of Climate Ready Boston and said, what would this look like as a sustainable park system that contains things like dune systems and salt marshes and stormwater wetlands on the inland side, but also contains a last line of defense, which is the multi-use path that you see adjacent to Washington Street. And it's an elevated berm. I want to delve into that elevated berm for a second here and just sort of tease apart the landscape that we've created. And as you can see, what we've done here is these are cross sections of that landscape that you were just looking at across Washington Street. And we're working with a design flood elevation of between 8 and 9 feet, which is pretty much the 2070 annual storm. It's referred to as the DFE, and it's what we chose because it seems like a great place to start. And all these predictions are based on the Massachusetts Coastal Flood Risk Model, which was designed by the WHOI group, which is who we're working with this project on. So basically the landscape, if you look at it in cross-section, goes up in that you have a series of dune systems followed by a dune face and a dune crest, all the way up to a berm crest and a multi-use path. That berm crest, as you can see below, actually does contain some form of coastal engineering structure as proposed at this time. It has either a steel sheet pile wall or a core roll or a geotube or something highly controversial in Nantucket inside that berm. Exactly what the design of that looks like right now is still up for discussion, but it is that last line of defense, and it's what actually is going to protect Washington Street from flooding if we were to implement this project. These are some of the pretty renderings that we get from our modeling, and I just wanted to start here before I really delve into kind of the math. And what you can see here is we have the 2050 projected mean high water without the project and then with the project. So without the project, you can see there's a lot of flooding across the site. And with the project, we've basically changed the topography of the site with a dune system all the way up to a berm, which will have some sort of engineered structure inside of it, and a multi-use path along the top. Again, the land bank is very interested in public access and facilitating public use of our sites. So, these are all components in addition to ecological soundness and resiliency that we can tie into these projects, which is just, frankly, fun. So I just wanted to go into the math that was behind this. When you create these pretty pictures, you think to yourself, well, how do you know it's going to work, right? And so we worked with the WHOI group, and we really did look through use the Massachusetts Coastal Flood Risk Model to assess whether or not this project was actually going to work, and what parts were going to work and what parts weren't going to work. And so this is the type of data you get from the MCFRM, where you can look at peak water levels. You can look at peak water levels for tides at 2030, 2050, and 2070. And you can look at peak water levels during different types of storm events. A 10% storm, which is one that happens every 10 years, probabilistically. And so that means it's a pretty bad storm. A 50% storm happens every 2 years, maybe a little more common. So we used the MCFRM, and then we took LIDAR data, which is what you're looking at here, and we basically looked at elevations across the Washington Street site. We looked at existing elevations in this site. We looked at existing elevations with that 9-foot berm, right, which is referred to as the long-term framework plan here. And then we actually looked at that, and we removed that. We put in the 9-foot berm elevationally, and then pulled out the private parcels. So what if you're having trouble working with private homeowners and it's not all, blissful and happy, and so some people want to participate and some people don't? Well, we don't have complete ownership of these areas. So what is flooding going to look like if you don't have all these private parcels included? And this is really just sort of an exploration for potential on the site. And then last but not least, at the very end, we actually, at the recommendation of the WHOI group, added in a commercial street deployable flood barrier. And you'll see why in a second, because basically through this iterative process of modeling, what we ended up seeing was that no matter what we did, there's a flood pathway on Commercial Street that can be resolved with something akin to a deployable flood barrier. And this is the type of data that we ended up getting. So here is an example of a modeling run where we looked at flood extents during a 10% storm in present day. So 10% storm, again, is something that happens every 10 years, not that frequent, pretty major storm event, right? So we have the potential on the left to have a series of flood pathways, which are shown with the white arrows. And these are the areas where water is actually accessing the site. And then if you put in that long-term framework, again, you have the 9-foot berm and the series of dunes, which leads up to it. You have, basically, you're left with flanking, right? You have flooding on either end of the framework system that was installed. And so that kind of starts to give you an idea of the efficacy and the problems with your design. So continuing on, basically what we did was we looked at the long-term framework, and we took out the private parcels. If you take out those private parcels, how does it change your flooding, right? So the private parcels do not have the 9-foot berm associated with them. And what you see is that in a 10% storm in present day, you don't have a ton of change, but where you have change actually is what you can see on the right-hand side. All that water is coming from Commercial Street. So there are private parcels along the edge of Commercial Street. So if you block that Commercial Street area and that flood pathway right there, it has so much greater impact than actually any of the private parcels along Washington Street. So you start to be able to look at, like, where's your greatest bang for your buck here, right? And what is the actual flood pathway that's making a difference? These are just continued model iterations. I just wanted to show people that when you have flood extents during a 50% storm in 2030, again, all from the MCFRM, you start to have a lot more flooding in your existing conditions. And then with your long-term framework, again, it's still looking pretty good. And a 50% storm is every 2 years, so it's a pretty common storm event. And then I just wanted to show this because this is flood extents during just 2050 high tide. So this is looking at when you've got that daily nuisance flooding, right? And by 2050, we have real problems on Nantucket. We're predicted to have quite a bit of just daily nuisance flooding happening that's going to blanket our streets. Again, with that long-term framework, we have quite a bit of success, but not without the commercial street deployable flood barrier. So we still have that flanking effect with our project unless we do something to block the flood pathway on Commercial Street. So this has been a great way to actually kind of look through our design and really take a look at the pros and cons. Continuing on with my pros and cons analysis of the Washington Street Framework Plan, this is an example which looks at erosion. One of the things we wanted to know was if you do create this berm, what kind of maintenance is it going to require? How much sacrificial sand are you going to have to put on top of it? Do you have to, put dump trucks and hundreds and thousands of cubic yards of sand every year to consistently maintain this site? Which is a major issue because the cost can be huge, and we've seen this in other places. So nicely, we chose Washington Street, where there's very little erosion to begin with. On the left-hand side, you can see that basically we're looking at a really tiny amount of accretion, a really tiny amount of erosion, but mostly no change in this site. It's not a high-velocity area. This is fantastic for us because it just makes it easier. And then what Woods Hole Group did was they basically looked at how much erosion would occur on this berm in a 10% storm in present day, a 10% storm in 2030, and a 10% storm in 2050. And if I understood how the pointer worked, I would show you that the little pink spots over along the berm face are basically the eroded profiles, right? So we're getting the tiniest little bit of erosion at this site during a 10% storm, which again is a pretty substantial storm. So we don't expect a ton of maintenance required for this project, which is also really quite a benefit. So continuing along, what we then did was we started to really go in depth on the Washington Street and Francis Street corner. We took kind of our long, Washington Street framework plan, and we said, where can we really look closely at how this design could work and how it would function? We chose Washington Street and Francis Street for a couple of reasons. One is because it's almost entirely owned by the town and the land bank. It is an issue where we have frequent flooding these days, and there's predicted to be groundwater issues going forward. There's also a number of stormwater outfalls in this area, which makes it kind of interesting. So this is what we came up with, and you'll see there's a very similar theme to what was shown earlier with Climate Ready Boston and some of the different plans, particularly our framework plan. There's an interesting theme that I see developing here, which for me personally is pretty exciting. So what we have here is we have a recreational beach, which provides a lot of public access, a beach deck, which again I want you to notice is at elevation 8. There's one important factor about that elevation 8 or elevation 9. It's actually a vertical datum elevation. So it's not actually this high. It's more like this high, right, on the ground. So it's about 4 feet high on the ground. So when you're driving by on Washington Street, actually that's not 4 feet at all, is it? Maybe more like here. So when you're driving by on Washington Street, it's probably about here is the height of your berm, but it's that last line of defense, right, that's protecting Washington Street from flooding. And that's the same for the beach deck here. We have this one at elevation 8, again, sort of equating to 4 feet. The other thing that I really wanted to point out is that across the street in this area, we have these stormwater wetlands, and these were also talked about earlier. This is a hugely important component of coastal resilience design, is what you're gonna do with the groundwater and the stormwater from all this precipitation on the other side of the property. So this was a great opportunity to really look at how we're gonna handle stormwater. And because I like modeling, we modeled groundwater levels under current and future conditions. And as everyone said earlier today, basically groundwater is predicted to rise for a number of reasons. Particularly on the coastline, you have the increase in sea level, which is actually going to add pressure and even force the groundwater up higher. So in this site, you can see that we're predicted to have a mean groundwater level increase of almost, over 4 feet by 2070, which is a really big deal. And by 2050, we expect to be seeing groundwater breakout in these sites, as predicted. So the area that I've circled here is the Meter Street, Francis Street corner, and where Washington Street intersects, which I was just talking about and just showed the plan for. And you can see that it's an area where we definitely expect to see groundwater breakout by 2050. I'm going to just focus in on this small area for a second. And what I want to go over is the stormwater system. So the way the stormwater system works on Washington Street is really interesting because, and this is just a small segment of it, but we have these series of catch basins, which then all flows down into, down pipes into outfalls, which go out onto the beach and into the harbor. Okay, so that's all good and well until you get sea level rise and your outfall pipe is mostly full of sea level. And then your precipitation that's upland can't actually exit out your sea level, out your outfall pipe. So this is an area where we've really been looking at what surcharge looks like. In Meter Street, we chose to look at this one outfall just for an example. And in present day, we have a lot of drainage. These are tidal cycles, and basically we have plenty of drainage occurring. When we get to 2030, and by the time we get to 2050, the amount of available drainage time, basically when the pipe is open and not full of seawater, basically decreases over time until you get to a point in 2050 where you have surcharge. So the sea level rise is such that basically you have ocean water coming out of your catch basin. So this is something that's really important to consider, which is why we've done these stormwater wetlands, because what you can do is you can reroute some of these outfalls so that your stormwater is actually going into the stormwater wetland and is then held with a tide gate that it's then able to exit when the tide is low and the outfall is not full of seawater. So that being said, on a high note, I really think that this is kind of a really unique opportunity to create these beautiful public open spaces that have recreational benefits, they have socioeconomic benefits, and they have resiliency benefits in that they can really protect inland infrastructure. And I think it's pretty exciting on Nantucket. So I'd like to say thank you very much to everyone who has helped with coastal resiliency on Nantucket, because there's a lot of us. And thank you so much for listening.
Any questions for Rachel? Okay, thank you, Rachel. Okay, so the next speaker is Cynthia Dittbrenner. Cynthia is the interim Vice President of Conservation and Resilience at the Trustees, where she oversees the natural resources, land conservation, agriculture, and policy teams. Cynthia also leads the State of the Coast initiative, providing the public with information on impacts of sea level rise and storm surge on our coastal habitats and communities. And they did a write-up on Nantucket, the Cape, and the islands a couple of years ago. Brilliant. Cynthia brings 20-plus years of natural resources experience in coastal and floodplain planning, habitat restoration, agricultural resilience, and climate change adaptation. She has worked for non-profit organizations and local government and has extensive experience building partnership and leading innovative approaches to natural resource management. Cynthia holds a master's in forest ecology and soils from the University of Washington and a certificate in non-profit finance from Cornell University. Please, everybody, let's welcome Cynthia.
Thank you, Vince. That felt like a long bio, sorry. I appreciate that you're all still here. I know it's lunchtime and there's me and one other speaker left. I apologize. I'm here to talk about Cosquedeco 2, a refuge at risk from rising seas, and this was a partnership with the Nantucket Conservation Foundation. Vince, thanks for your compliment on this report that came out a few years ago. So we've been doing State of the Coast reports yearly for the last 3 years, and this was the second, and it came out in 2021. And the idea is to pull together all of the state and federal information we have on the impact of rising seas and storm surge on our local communities. So this report talked about Nantucket, Martha's Vineyard, and the Elizabeth Islands. I'm not going to talk about this slide. We've had this slide many times today so far. Actually, I am going to talk about the one on the right. So the graphs on the right, on the very left, it shows historic. These are storm surge levels. So the orange is a 10-year storm, and the dark orangish red is a 100-year storm. So happens about once in 100 years. So if you look to the middle bars, that's 2050. The interesting thing for me is that the light orange, which is the 10-year storm, is the same as a 100-year storm now. So what would have been a once-in-a-lifetime storm is going to be happening more frequently, perhaps every 10 years. And that's a high sea level rise scenario. So here's the refuge I'm going to talk about. The white is owned by the trustees, and the pink is owned by Nantucket Conservation Foundation. So as you can imagine, they're both very much integrated. We work together to manage this beautiful wildlife refuge. Okay, so this down here, which you saw in some of the other maps, is the town of Nantucket. So looking at this map makes you realize this thin little delicate strip of land is creating Nantucket Harbor and protecting our infrastructure there. And Leah showed the billions of dollars of damage that could potentially happen with rising floods in the town. I'm guessing that those flood scenarios didn't model a potential breach to that barrier beach system. So we were concerned about a potential breach and worked together with NCF to come up with an approach for assessing that risk. This is a very dynamic system, as most barrier beaches are. Sand moves, water moves sand, things breach, and then they refill. That's just the nature of barrier beaches. We just kind of approach an area in a point in time and expect it not to change, which is maybe a little naive. Here's a picture of the Haulover site on the refuge in 1896. This was a breach. So it's called the Haulover because mariners used to just pull their boats across it so they wouldn't have to go all the way around when they were fishing. It's much wider now. I don't think you would do that. But they were actually planning to breach it, and then a storm came in and breached it anyway. And this stayed open for about 10 years. Here's also some pictures from the Gulls, that thin strip of land that goes out to the lighthouse, breached in the early 90s. So this is expected, right? But with rising seas and increased storms, is it going to happen more frequent? And if it breaches, will it stay breached? These are the 4 points that we looked at with NCF where we thought there was some vulnerability. The ones that we focused on were the first two, A and C, Haulover and Cosqueda Pond. These two. The Gulls is very dynamic and could breach and cause problems with access to the lighthouse, but not huge issues with the harbor. And then this one, NCF is working on maybe some changes in management to protect the dunes and grasses that are there. So we hired Woods Hole Group, which seems to be a theme in this conference as well. Is Tara here? I didn't see if she came. So we hired them to do an analysis. I call this the AAA report, Assessment and Analysis of Adaptive Interventions. The one that we did on Martha's Vineyard is Assessment and Analysis of Adaptive Alternatives. Come on, guys. We got to get some better names here. So anyway, they did an assessment, and I'm going to show you just a few slides of what they came up with. I don't know if you can see the lines very well. So they combined rates of erosion with rising seas, overlaid those on top of these two, actually the 4 potential breach sites, and showed us where the shoreline would be in the future. So on this one, it's eroding from both sides. There's a black line here that represents right now, and then it's creeping in over here. And then in 2050, this brown line, This is the backside brown line. This is eroded all the way in, and here's the other brown line. So at 2050, we've got this little sliver, and then by 2070, the shoreline's here, meaning that it's underwater at a high tide every day. So effectively a breach. This is the Cascada Pond site, which is just north of that. And we don't even see the 2070 line on this one because by somewhere between 2050 and 2070, expected to be underwater daily at a high tide. So one of the reasons we care about these two sites is because if they breached, there would be movement of water from the open ocean into the harbor. And that differential causes velocity of water, which could potentially keep the breach open longer. And it would also have impacts to water level and waves in the harbor and the buildings along it. This is also the map for the small strip that heads out to the Gulls and the lighthouse. It's projected to be breached sometime between 2050 and 2072. But again, the sand is moving in this direction. This one may just be dynamic breaching and rebuilding over time. I wanted just to add, I'm not going to present any information from this, but Boston University is doing a follow-up study to the Woods Hole Group study where they're looking at sediment transport and breaching risks. The interesting part of this study for me is that they plan to create a model where we can model different scenarios. So I keep saying, I don't really know what's going to happen if it breaches, but we think the water levels will be higher in the town, there'll be higher wave energy. So to create a model where we could actually see, and I've talked with Vince and Leah, we're hoping to work together to maybe make something happen if the BU study doesn't end up doing this. So I'm going to show you a video, but I'm going to show you this last slide first. Oh. So we created this cool video. There's several people in this room right now who are in the video. I'm going to hopefully show the trailer if it works. You think it'll work? Okay, I got a nod from the IT guy. So it's an 11-minute video. I'm going to show you the trailer, which is only a minute and a half. And it was staff and community members talking about, and Woods Hole Group talking about the impacts of sea level rise on the wildlife refuge and then what we could potentially do about it. We decided to try a new medium, and the video was what we came up with, and it's funded by Remain, so thank you very much, Remain, also. And it got into the Nantucket Film Festival, yay! And the Woods Hole Group Film Festival, so I don't know, they probably just said, ooh, local film, we'll throw it in. I mean, it's really good, but and maybe, well, I'll let you guys judge. So anyway, it's going to be showing twice at the film festival with Patrick and the Whale. If you buy tickets to Patrick and the Whale, you can see it. And then we're going to do a community event on August 24th, where we'll invite you all to the Dreamland, and you can come see it for free and have a little talk with us afterwards. So the idea behind that is make sure that the public understands the impacts of climate change on the refuge, and then we can start to engage them in saying, hey, here's the types of things we're planning to do. We have a couple funding requests in to fund an alternatives analysis and design, so the early stages of planning a project at these two sites to increase resilience. And we're thinking about some interesting, innovative ideas besides just dumping sand, which they're probably part of the dumping sand, but maybe also on the back side of the barrier beach, doing some of these breakwaters that some people have talked about, the oyster reefs, to slow water and build up the marsh. Okay, I'm gonna do a video.
Just purely based on the science, sea level is rising, and it's rising at an accelerated rate.
But New England is actually seeing more accelerated rates than anywhere else in the world.
By 2050, on the island of Nantucket at a high tide, we're expecting to see over 25 miles of road inundated and over 600 buildings inundated.
The Cascada Wildlife Refuge is what defines the harbor of Nantucket.
The refuge buffers the town from intense storms, from intense wave energy. We expect the beaches and our natural areas to change. But when we've built a town behind a barrier beach system, a potential breach could cause devastating consequences to the town.
We might lose the ecology of what's in the harbor.
I've been studying these beaches for 30 years. I see dramatic changes.
We can't look at our children in the eye and say, we did nothing, we didn't even try.
It really matters the moves that we make in this immediate time. We have an opportunity, and we don't want it wasted.
All right, thanks all.
We have time for one quick question from Cynthia. Does anyone have a quick question?
When's lunch? One more?
Okay.
Okay.
Thanks, everybody. Thank you, Cynthia. Before we get to our last speaker, can we give a big round of applause for NCTV, who have been working through some amazingly difficult tech problems today. Those guys have been brilliant. Okay, so the last speaker we have today is Joanna Roach from the Maria Mitchell Association, and she's going to talk about acclimating coastal resilience education on Nantucket. Joanna is the Executive Director of the Maria Mitchell Association, a non-profit organisation dedicated to exploring the nature of Nantucket, and it was founded in 1902 and dedicated to preserving the legacy of Maria Mitchell. Maria Mitchell was a Nantucket native, a naturalist, and America's first woman astronomer. Joanna also serves on the Coastal Resiliency Advisory Committee and has been a member of the Finance Committee for the past 8 years. She co-founded the Clean Water Coalition together with Samantha Dettel from the Nantucket Shellfish Association and Emily Molden from the Nantucket Land Council. The purpose of this is to help people understand that the cleanliness of our water is under our control and to develop the best practice in partnership with the town. Joanna is also a member of the steering committee of Acclimate. Can we all please welcome Joanna Roach?
Okay, hi everybody. I'm happy to be here, and I won't take too much time since it is right before lunch. But I'm going to talk a little bit about this walk that's been developed and talk a little bit about Acclimate. Oh, here we go. So most of you are familiar with Acclimate, which is an organization that was really started by Will Kinsella and the Osceola Foundation. And it's a collaborative that supports innovation and holistic climate change strategies for Nantucket and the community beyond. Many of you in this room are involved in this effort. Obviously, you can see all of our members. Most of you are here. And what Acclimate is meant to be doing is developing a public-private partnership with 20 organizations, mainly science organizations, that really look to adapt climate change and communication and collaboration along with coastal resiliency. I think the thing that Acclimate has been the most successful with is developing September as Climate Change Awareness Month here on Nantucket. They've done a really good job with that. They've engaged the board of select people and have created a lot of events during that September timeline. And in that same sort of spirit of collaboration, the thing that they've been most recently working on with several people here, including the NHA and the other science folks, is this walk, which I think is going to be really cool. It's a 1.5-mile walk from Brant Point to the creeks along Nantucket's past, present, and future, which really will look at strategies for living with changing coastal conditions. Obviously, the history of Nantucket has a lot of, 12,000 years back, has a lot of different conditions that it's had to deal with, including the first indigenous Wampanoag settlers who really were nomadic here on Nantucket based on where the food was and how severe the weather was. So the Coastal Resilience Walk takes place down along the harbor, and on the website you should be able to connect all the way through to an example of the walk. And basically how it works is that you would walk, it's a 1.5 mile walk from Brant Point all the way to the other end of Washington Street, and there are 6 spaces along the walk where you can stop and scan a QR code and learn something historical about what the what it looked like 100 years ago, what it looks like now, and what it might look like in the future. And they've really pulled heavily on remains information from the Envision Resilience studies, and so it's very thorough, and it will be launched in September. So my apologies for the glitch with the website, never what you expect. But the walk will, I think, be effective for Nantucket because it's active and because it captures some basic level of education around what's happening in terms of real-time climate change. So I thank you and appreciate your time today.
So, thank you everyone for coming back to lunch. Now we get to hear about some of the nature-based solutions. Our first speaker is a repeat offender. Jen was here back in 2019. Dr. Jen Carberg is the Director of Research and Partnerships for the Nantucket Conservation Foundation, overseeing the Foundation's ecological research program, particularly focused on wetlands and coastal ecology. She is a longtime member of the Society of Wetland Scientists and chairs its Women in Wetlands section. And she currently represents NCF on Nantucket Coastal Resilience Advisory Committee, and she's very proud to have installed the state of Massachusetts' first intertidal oyster reef on oyster castles. So if you would, welcome Jen up for our next talk.
All right, good afternoon, everyone. Welcome back from lunch. Today, I'm going to talk about a coastal resilience pilot project that we've implemented at the Nantucket Conservation Foundation, and it's looking at an oyster reef and how it's helping protect salt marsh health and how we're dealing with sea level rise. So since this section is kind of really starting off the implementation of living shorelines and nature-based solutions, I like to use this graph a lot when I'm teaching about coastal resiliency and coastal ecology on the island. It's from NOAA and talks about living shorelines and how they support a resilience community. You'll actually see that I have a yellow box here around some of the kind of important key benefits of nature-based solutions that apply to salt marshes where we're implementing them. And that's the idea that we try and use these nature-based solutions for resiliency for both ecological reasons and because they're helping us with coastal resilience. Salt marshes trap sediments from tidal waters. They actually naturally grow in elevation, which makes them on their own a great sea level rise adaptation tool, as long as we can help facilitate that salt marsh grow with sea level rise. Living shorelines improve water quality. They provide amazing fisheries habitat, increase our biodiversity, all things that are really important from an ecological standpoint, but they're also really great for recreation. People would much rather kayak along a salt marsh as opposed to kayak along a hard seawall. It's just something that's much more accessible for people to experience. And then we're going to tie in oyster reefs to that in the fact that oyster reefs provide amazing water quality and ecological benefit. So when you combine an oyster reef with salt marsh, when you're thinking about resiliency, you get all of these amazing benefits that can help, that are both ecological, but that can also help mitigate storm surges, sea level rise, water coming into an area. So that's kind of the lead up to why we thought about implementing a project that I'm going to discuss here. This is our area of interest. This is Pulpus Harbor on Nantucket. In the green here, this is the Medowie Creek Wetland Complex. And actually, if you look, there's kind of a dike road here that was put in the 1930s and actually ended up taking the salt marsh and splitting it in half, isolating the back part of the marsh from salt water. So it turned into a freshwater marsh system. And if you've been following some of the restoration work that we've done on the foundation over the past many years, This was one of our first big restoration projects. Back in 2008, we actually opened up this dike road so that tidal water could move back into that marsh area and help restore that salt marsh. And it was an amazingly successful restoration project. Just by reintroducing the tidal saltwater salinity, we were able to convert a good majority of this marsh back to the salt marsh that it previously had been, to the point where it's actually habitat for salt marsh sparrows, some other, rare and interesting bird species. Like, the ecology restored itself pretty well back here. But then we started noticing some other changes to the salt marsh. About 2015, we started seeing these areas of bare soil that were showing up in the salt marsh. Kind of unexpected, isn't something that you want to see in a salt marsh, because when the soil of a salt marsh isn't held in place by the roots of a plant, it can erode away really easily. Like, even just with regular tidal events flushing and coming in and out can actually take those areas of salt marsh soil away. And we were starting to see erosion happening within our salt marsh creeks where we had these areas of exposed soil. So we started trying to figure out what the heck was going on here, because we had no idea. We'd just done this amazing restoration project that had worked, and now we're losing plants. And we started researching it, and I'm sorry for you guys on this side, because there's a graphic down here that you can't see. But what we actually found is that the purple marsh crab, which is a native crab in New England, and when its populations are released, when its predator isn't present or something changes in the nutrient dynamics in the salt marsh, this crab's populations actually skyrocket. And this crab loves to eat the grass that's in our salt marshes. It eats all of it from the top of the grass all the way down to the roots and takes it away and actually creates this area of salt marsh dieback. And we looked at it, and there were places on the Cape where this was already happening. So we could determine that that was the cause out here. We did some trapping studies to look at the marsh populations. And then we asked around, because we were losing salt marsh sediment. And there were other researchers in places like Rhode Island that said, oh, just wait 10 years, and the crab population will go down and the marsh will recover. And we didn't want to wait that long. So we actually started removing the crabs. In 2019, we started this, and by removing it, I mean we put out traps, and we actually act as predators for the crabs, and we take them out of the ecosystem. Our goal was to see if we did this removal of the crabs for a couple of years, would the grass start to grow back on its own, and hopefully we could restabilize those salt marsh sediments. We've been doing that for a number of years now. We tried to outplant grass. That did all right, but we had some issues with 2020 and shipping grass to us. But we've actually had a lot of success with salt marsh grass growing back just by removing the crabs. So this is a picture that's within that dieback area, and all this grass here has grown back just by taking the crabs out of the picture. Now, I kind of give you that background because it's what led us to putting in our oyster reef. So as this was happening, we realized that, okay, we're growing the grass back, but we still have a lot of exposed soil. It's going to take a while for us to get this marsh completely revegetated again. And I'd like to see if there's other ways that we can improve resiliency in the marsh and reduce erosion of those soils in the marsh. And so we decided to look at doing an intertidal oyster reef. These have been put in place in a lot of other places around the country. Chesapeake Bay particularly has used a lot of intertidal oyster reefs. And if you look at this diagram, so you can put a reef right here, almost like a break wall, and you can protect your soil sediment, your salt marsh back here. But we wanted to do something like this, just so you can see the graphic. What's happening in this graphic, you can see there's an oyster reef that's under the water here. Having that oyster reef in that intertidal area is slowing down and taking the energy out of those waves that are hitting the shoreline. Because it's intertidal and offset, behind the oyster reef, there's actually a place for sediment to slow down and settle behind that oyster reef. So we're getting protection of this shoreline because those waves aren't hitting it continuously, but we're also hoping, and this is what we're starting to track, is whether or not enough sediment can fall behind that oyster reef that maybe the marsh will actually move towards the oyster reef. So when we're talking about sea level rise in marshes, we often talk about marsh migration backwards as sea level rise is coming up. We're hoping to see if we can get the salt marsh to actually move forward and build a little bit more salt marsh area behind where the oyster reef is. So back to this locational photo, here's where we are. The oyster reef went in here right at the mouth of this salt marsh complex where we've done all this research. We also have a reference monitoring site over here as well. This, as we mentioned in the introduction, this is the first one that's been permitted in Massachusetts, so the permitting process took quite a bit of time, and there's quite a bit of monitoring that the state wants associated with this project so we can show proof of concept out here. So that's why we have the reef area and the reference area. So this is the site before we did anything. You can see the mouth of the creek here. You can see this is at a super, super low tide for the area. We did a lot of surveys out there. We came up with pretty much no submerged aquatic vegetation. We looked for shellfish in the area. We found one quahog clam on all of our transects. There was not a lot that's happening in this area of the harbor. It's for Nantucket, a pretty ecologically degraded piece. That meant actually that it was easier for us to get the permitting through the state. You can see our design here of the reef that we're putting in place, and I'll show you a picture of the castles in a second. But we designed the height of the castles and how we stack them up based on monitoring what the water level did in that area to make sure that the oysters wouldn't be exposed with no water for a long period of time. And we also found, I should say, spat collectors that we put out in 2020, and we found absolutely no oyster spat in the area. This is to show you the same area now with the reef in place. And I've got a lot more pictures of the reef to show you, but just that side-by-side comparison. And these are the oyster castles. I like to call them adult Legos or ecologist Legos. They're actually very similar to the oyster reef balls that Leo was talking about. They're concrete that is attractive to oysters to actually attach to. These guys are completely square and they're hollow in the middle, and you can actually see they're called castles because the top kind of has this crenellation to it, and that helps them fit together very snugly so that when you build a reef, they interlock together, and you can actually build up a fairly stable structure. I should say we worked with the town of Nantucket hatchery to actually grow oysters and set them on about a third of the castles that we used to build this whole structure. So we sent them a whole bunch of our oyster castles, and they were able to grow oyster spat and then get it set on the castles. And what you can actually see here is the start of our installation process, where we had a massive amount of volunteers help us get those castles from the hatchery out to the site in Pulpus, and then actually build the oyster reef. So I mentioned the permitting for this took a very long time, and we got the thumbs up that we had received all of our permitting in like the second to last week of October of 2021. So I looked at the tides and I looked at the weather and I was like, so guys, it kind of looks like maybe it's going to be in the 60s and sunny next week. Do you want to go in the water and help install an oyster reef? And amazingly, 1 million people came out to help us do it. And so we did this all by hand. This was completely a group effort. You can see here we had a small flotilla of boats that helped us bring oyster castles that were from the shoreline out. And then we did it at the low tide as we constructed this oyster reef. Tide comes up pretty quickly, so we were often working underwater as we were doing this, but we built up those 3 layers of oyster castles to construct that stable reef. And this is what it looks like. So this is the structure that we ended up going with for the reef itself. Here is the salt marsh. Here's the main outlet channel. You can see some of the dieback back there. So we structured the reef so that it would cross this opening and protect this primary area of the shoreline. That's where we wanted to slow down impacts to the shoreline, slow down water moving up and into that channel. But we didn't want to do one straight hard line because then water wouldn't be able to move in and around as naturally as we wanted it to. So we have 3 lines here of the oyster reef. This one's still being finished. There's 2 close with an opening and then 1 on the outside. So that ends up allowing water to move through and in and out of the salt marsh, but there's still enough area so that it can slow down those wind and wave impacts. And I should say that most of the water, when it's coming into this area of the harbor, is moving from that southwestern direction up against that shoreline. And so the reef is angled that way a little bit, and you can kind of see some of those waves in here coming up at that angle as we're putting it in. So the reef was completely installed in November of 2021, and since then we've been doing a lot of intensive environmental monitoring out there. You can see we have transects that are within the area of the reef itself, transects adjacent to it, and transects within our reference area. And we're monitoring all sorts of things, from looking at the health of the oysters, health and size of the oysters, which is this picture you're seeing here. We're monitoring elevation around the reef itself, but also in the salt marsh, because we're trying to prevent erosion in the salt marsh. See how much sediment we gain behind the reef itself. We have this nifty logger called a tilt meter that actually moves with the water that's coming in, so we can track how the reef is changing the dynamics of water movement coming in and out of the salt marsh itself. And then we're looking at vegetation in the salt marsh to look at health. This is our status after 1 year. We actually went out and sampled last week, and I didn't get a chance to update the slides for that. But our oysters are growing really well. We actually saw spat on the oysters that we looked at last week. And if you'll remember, back in 2020, our spat collectors didn't collect any spat at all. So there's at least oyster spat that's within the water column, whether it's from us or other oyster farms nearby. And then let's see if this works. You can look at this picture here. You can see the water outside the reef and the water behind the reef. And it might just, so watch it, it might just go really slow. Yeah. You can see the change in the dynamic of water flow on the other side of the reef. Now, of course, the water gets high enough and will go over the top of the reef, but there still slows down water as it's moving over that reef. We've seen a lot of sediment accumulation behind the reef. It's only we're entering our second season of monitoring out here, so we still have a lot that we need to learn. But so far, the oysters are growing well, they're happy and healthy, and it seems like we're protecting the marsh pretty well. And then in case you are wondering, this is that crab research with the grass regrowth. This is taken at the same spot over a couple of years. That's 2020, 2021, 2022. And so there's massive regrowth of the grass just by pulling those crabs out. And then the added benefit of the oyster reef will hopefully improve water quality and help slow down erosion over time. And a lot of people helped out with this project, and I'm happy to take any questions. We have time? Yeah. Leslie. The oysters will be suitable for eating, so I think the rule of thumb is 3 years till that kind of letting them get to sexual maturity, and then we could potentially start to harvest them off the reef. With our permit, because we have to have a permit through the state to have the oysters as a scientific research program, we'll be able to run some like events or experiences, maybe with school children actually, or getting some people out and learning and harvesting a few oysters. In the back. Yeah, you.
Do you have any idea on the number of oysters that were introduced to the area?
Good question. The question was, do you have any idea about the number of oysters that were introduced to the reef? Leah, do you remember our spat on shell number, or our spat on castle numbers? We could get it, yeah, 1 million. It was a very high number. I just don't remember off the top of my head. Shay?
What are you attributing the population boom of the purple marsh crab to?
So the question was, what are we attributing the boom of the purple marsh crab to? So this phenomenon has happened other places, Cape Cod, Rhode Island, and the research work that has been done there has turned up 2 potential. One is the reduction in a predator overfishing in a harbor area. So there's been excessive fishing and pulled out, sea bass, the black sea bass eat the crab larvae. That could be a potential to have the population boom. The other has been nutrient flush into the salt marsh. So there's excess nutrients, and then when the crabs are eating the grass, they have extra successful reproductive cycle. I wonder if that's the case here due to our restoration. Sometimes restoring a freshwater marsh to a saltwater marsh like this, you get a flush of nutrients. But it's something that we knew what the problem was, so we went after the problem with the crabs themselves to see if we could get a handle on that. Good question. Okay, one more question. Yeah.
I know this project is only 2 years in the making so far, but given the seemingly success that you're having now, is there anywhere else that you'd be interested in implementing it?
That is a really great question. So the question is, there are other places we'd be interested in implementing a project like this? I see this pilot project as something that it would potentially be, once we get it through and the state approves it as a good project for coastal resiliency, is a good small-scale project, and there's a lot of places it could go in. It's something that potentially even private property owners that are experiencing erosion within our harbor area could think about doing something small-scale like this that would improve the number of oysters that we have and then also improve coastal resilience. So I don't necessarily we might think about doing it out on the refuge, the Koskata-Kotu Wildlife Refuge, but otherwise I think that there's a lot of ways it could scale up on the island. Thank you.
That was great. And who wouldn't want to play with oyster Legos? Sounds fun. Okay. Our next speaker is Steve Kirk. He's the Coastal Program Director for the Nature Conservancy in Massachusetts. He's a former oyster farmer and captain of tugboats and tall ships. He now leads the Conservancy's efforts related to aquaculture, nearshore habitat restoration, and living shoreline-related resilience work in Massachusetts and regionally. His talk is titled Nature-Based Solutions, Opportunities and Challenges for Shellfish Restoration and Living Shorelines.
Hi, everybody. Thanks for having me. This is a great turnout, and this whole conference is like culminating in the last presentation right from the very beginning with a lot of the work that my team focuses on. So I'm Steve Kirk. I'm the Coastal Program Director for the Nature Conservancy in Massachusetts. For those that aren't familiar, the Nature Conservancy is an international environmental conservation organization. We have offices in all 50 states in north of 75 countries, with a vision, seeing a world where people and nature thrive. And to do that, it's like right to the first speaker and talking about the decisive decade that we're in. The Nature Conservancy has set 2030 goals that really are in line with things like the UN Sustainable Development Goals and the Paris Accord. Really, these goals are designed to address the challenges of our time in the climate crisis and the biodiversity loss crisis. We're here talking about at the Coastal Conference, we're here talking about estuaries and estuary health. The stage has been set here in really recognizing the value of the different habitat types that are within our estuaries, but thinking about salt marsh, seagrass, shellfish populations, the ability for those habitats to sequester and store carbon, the ability for them to absorb water from a storm surge and from a sea level rise perspective is critical from obviously from a resilience perspective. And the threat that they're under, really from coastal development and our land use practices, one of the, really big drivers here is around nutrient pollution on the islands and the Cape in particular, thinking about how those threats are being fueled, and increased with the climate change regime that we're in. So I have sort of two elements of what we're going to talk about here between the importance of shellfish in our estuaries, and great lead-in from the previous talk. The Nature Conservancy has done quite a bit of shellfish and oyster restoration. nationally and internationally. It is, as you've just heard, it is really in its infancy and a nascent practice here in Massachusetts, one that the Nature Conservancy and my program is committed to advancing. But really the recognition that healthy shellfish populations are a really great tool to address the eutrophication or overabundance of nutrients in our estuaries. That's like a primary driver for why we're thinking about trying to expand this practice. We have staff that are working at the source, in our area and in our region of southern New England. The introduction of nutrients from how our wastewater is treated and in the distributed network of septics that lead excess nutrients to the estuaries. We're working on that problem, working at slowing the flow of water from the upland toward the estuary. But once the nutrients are there, shellfish are a really powerful tool, not only potentially on their harvest in the case of wild harvest fisheries and aquaculture, but also in their ability to sort of kickstart the microbial process of denitrification, which is something that I won't talk about the specifics of right now. So, there are relatively few shellfish restoration projects and oyster restoration projects in particular in Massachusetts. There's a long history of municipalities planting shellfish. So I mentioned that TNC has done a lot of this work outside of the state. There are a lot of people that have done a lot of work related to shellfish in the state. There are people in the room that have, at the municipal level and otherwise, that are really good at growing shellfish and planting it out in our coastal waters. We're thinking about the value of increasing shellfish populations and sort of harnessing the power of these species to do the good ecological work that they do. We can look to the aquaculture industry to provide many of those same benefits. So with a well-sited and with a well-managed farm, we see many of the same benefits that we're going for in a restoration project, from the provision of habitat, depending on the gear type that a farm may use, to just having more animals and the filtering capacity to improve the water quality. I'll talk about a specific project that we've worked on, sort of merging these things, the restoration sector and the aquaculture sector. So in a bit of a COVID relief effort, when the markets for shellfish, the markets for any food in a restaurant evaporated at the beginning of COVID, we recognized that there sort of like a lemonade opportunity here, where the growers have oysters that are ready to go to market, but they don't have a market. TNC, along with others, were able to raise funds, purchase oysters from those growers, and plant them out on restoration sites. And so that happened in Massachusetts, that happened in several other states, and now one thing that we're working on is really trying to institutionalize that model of farmer-implemented restoration, a way to shore up the industry because they are providing good value, and to try to bring their expertise in husbandry and growing animals, and with the infrastructure to be the implementers of building habitat restoration projects. We're working with a branch of the USDA, which is the Natural Resources Conservation Service, to help identify new restoration sites. And one of the criteria that we're bringing to this site selection process is where there might be a concentration of farmers that would be interested in participating in a model like this, ultimately with them funding the work. So we're thinking about nature-based solutions and sort of addressing the problem in the near shore area, from restoration and aquaculture, You'll see in the picture, this is, I think, not the same image, but an image of the same project that Leah showed earlier with these reef balls. This is the project in Connecticut at Stratford Point. So the oyster castles are like as big as a bread box, and these reef balls are more like half of a Volkswagen. They're like 6 feet high and maybe as wide. So just to give a sense of scale, but a very similar project type where there was some work on the upland to sort of up the beach profile around salt marsh plantings, but then working further down the profile into the intertidal and subtidal area. So I'm going to reference a sort of body of work at the regional level of New England. The Nature Conservancy has been working primarily with this umbrella group, the Northeast Regional Ocean Council. And in particular, there's a subcommittee of that group called the Coastal Hazards and Resilience Committee. And they and we have been really interested in trying to advance the policy and practice of living shorelines in New England. So there are several sort of products that have come out of that work stream, and some of it has been just sort of characterizing what living shorelines are, a recognition that there aren't that many projects in our region in comparison to other parts of the country, and that they're sort of slow to being adopted here, sort of a similar story to the oyster restoration work. I think there are some good reasons for that. If you look at the Chesapeake or the southeastern part of the country, we have different conditions here. We have a shorter growing season. So if you plant Spartina, you only have X number of months for it to grow in comparison to a place that has a lot more summer-like months. If you get north of Cape Cod, this is a regional project, we're talking about a tidal regime of 8 to 12 feet, which is just different than another part of the country. We have ice, so these are all things that I think are very real reasons why it's not like a plug and play from project types that might be suitable here, but from different parts of the country. So let's see here. I'm going to talk for a moment about sort of the regulatory, which I think is sort of being, there was a reference earlier to like the permitting taking a really long time for project types, and that is true for the most part, and particularly as you go sort of further down the beach profile and into the areas where you start to have regulated resources and regulated species. And so if you need to get a Army Corps of Engineers permit, there are environmental safeguard laws that are meant to protect valuable species and valuable habitats. And those laws and regulations have done really good work at stopping bad development at the shoreline and into the intertidal. That's sort of one element of what we think is this sort of positive feedback loop of there just aren't that many projects around in the region, again, in comparison to other parts of the region. So there isn't really a high degree of confidence in their performance or the understanding of their impacts. And so then you don't really have a driving demand of the potential for a homeowner, for a town or a state agency to say, like, we really want these projects, which feeds into another sort of stakeholder group, the design, build, and coastal engineering. There obviously are sort of forward-looking and well-educated firms that are doing living shoreline type projects, but probably fewer than are really good at like putting out riprap or building a seawall. And with all of that and the lack of project work and the lack of information on the performance and the impacts of these projects, there's a bit of either recognition or perception that the regulators, those that need to sign off on a permit for these project types are sort of unwilling or don't have the ability to permit. these projects. And I think that it's more nuanced than that. These projects are permittable. We have living shoreline example that was just given in an oyster restoration example. We were showing the Stratford Point in Connecticut. There are bank stabilization projects, dune restoration projects that are all in this sort of broad category of living shoreline that are permittable. But there are a number of factors that make it so that these projects aren't coming to fruition at a really rapid pace. And so that's something that we have been working on with this Northeast Regional Ocean Council and other partners. So there's more to come on that. Just some recent news. If you're going for an Army Corps permit, there's a new general permit. So we live in Massachusetts, which the rest of the country has they call like a nationwide permit for different project categories. But we have our own general permits here in Massachusetts, as the other New England states do too, which is just because that's who we are. So this is a sort of hot off the press. There is now a general permit for living shorelines in Massachusetts. So I think a bit of the take home here is that that nature-based solutions, whether they are addressing the challenges on the upland side and thinking about, these are really intertwined and interconnected challenges that we're facing, from nutrient pollution fueled by climate change that are challenging and sort of decreasing the resilience of our coastal communities. But the natural habitats of our estuaries and our coastal zone is incredibly valuable and brings us so much resilience that the protection of those habitats, the rebuilding of those habitats, and improving the conditions all the way from the upland to the near shore is got to be something that we really dig in on. And thanks for the organizers pulling this together, because that's exactly what's happening. So I don't know if there's time for a question, but thanks. Yeah, go ahead.
The new general permit, will that hopefully speed up the permitting time?
Yeah, so the question was about the new general permit, and is there an expectation that the speed of review and issuance of permit will change? It's really hard to say. I think, again, a lot of times it's not necessarily the words on the page that has been the true barrier, but it's like every sector of late, there's a lot of turnover and loss of institutional knowledge. And I think, the workload for those that are sitting in the chair with a stack of projects to review and permit is one element in why this takes a long time. And I think to be sure that people don't take this talk as like a bashing of regulators or permit reviewers, because they have a really hard job in weeding out bad and good projects, of which I am told there are a lot of bad ones. And so I think I would be surprised if the speed dramatically changed because of this new permit.
Thank you, and I think just a point is that if we're going to get anywhere in terms of making a dent with these coastal resiliency projects, permitting on a state and federal level, Jeff and the others, they do a good job expediting on a local level, but on a state and federal level, it has to be expedited, and also allow us different tools in the toolbox for some of the state permits as well.
Yes, go ahead.
Question on acidification, ocean acidification. In 2021, there was a mass report on ocean acidification. I'm not sure what's been done with it, but there was a series of 8 or so recommendations at the end, conclusions. So I'm wondering if you know anything about that. Second question, corals and seagrass and coastal acidification and resiliency. Potential relationship there?
Yeah, the question was about the ocean acidification and an update. So I am familiar with what went on with the ocean acidification. I was a member of the Ocean Acidification Commission that helped to generate the report and recommendations. There are several pieces of legislation that are, like filed now or soon to be filed. I think one of the interesting things about coastal acidification, which is, our keynote speaker did a great job of outlining climate change as a global issue. When you get down to the local, the more local ecology and systems that are driving acidification in our coastal waters, in many ways, the ability to manage stormwater and wastewater drive acidification more than, say, CO2 and emissions. And so I think a lot of the things that we're talking about here and talking about development, management of storm and wastewater is going to be supportive of the ocean acidification and coastal acidification challenge. Thank you.
Okay, our last speaker for this session is Dr. Dijin. He's a senior scientist at the Marine Policy Center of Woods Hole Oceanographic Institution. He's been involved with so many interesting projects with that center. He's obviously not going to be able to talk about all of them, but a few of the projects involve valuation of beach width, cobble berms, build back versus buyout, just to name a few. Feel free to hit him up during break if you want to talk about some of those too. But today he's here to talk about an integrated assessment of shoreline protection options. And this is really built upon his specialty of integrating economic models with environmental models. So if you would, welcome Dijin.
Yeah, thank you, Greg. And I also want to thank the organizer for this wonderful conference today. I've been learning a lot and since this morning. So for me, I'm going to offer a slightly different perspective, which is from the economic perspective. So I'm going to talk about cost benefit, whether investment is justified or not. So I think it's an important factor to be added to the issues that have been discussed today. So we know there are generally two options. One is to protect shoreline and sort of to defend. Then the other option is to pull back. So the technical jargon is a managed retreat or relocation. So there are two, so most of the talk is going to be focused on the coastal protection. And then I'm going to come back on the relocation option at the end of this talk. So there are generally two options, green and gray. There's no need to expand on this because our speakers have explained this wonderfully. And so one thing I want to add for the green option is that from my review of the cases, it appears that the hybrid version is probably the most effective because you get the best from both. So the gray component provides you with this sort of a very reliable defense. Then the green component offer this ecological benefit. So when you put the two together in terms of economics, you get the net benefit maximized. So again, this is a slide summarize of the ecosystem benefit associated with the green option. And so it's been discussed in various talks in the past. But one thing I just want to add here is that this morning we heard the cost of constructing the defense is like $30-40 million. Then the benefit is like 3 to 11. If I remember correctly, that seems to be low. I think one of the reasons is very often, I think the researchers fail to account for the health benefit. There are emerging, actually growing literature on the health benefit associated with the green option. And so there are documentations of reductions in the ADHDs in nearby schools because of this waterfront park. And so just to give one example. Then the other one is tourism benefit. So in other words, most of the living shoreline cases, they're sort of in the suburban or rural setting. And then in the urban areas where you have this large population, then in particular, you have lots of transient population. You have visitors, they stay in hotels, they take a jog in the morning in those parks. Those are the benefits are often not included in the benefit estimation. So here is the reason why I just mentioned these two particular examples. So to me, people are reluctant in investing in living shorelines, or so far we haven't seen many more. It's because I think people still wondering whether the investment is actually fully justified. Because from the literature I reviewed, most of the projects are actually funded by NGOs or by foundations, but not very often it's funded by sort of private investment into this thing. So to us, my colleagues and myself were actually developed a framework to augment the traditional benefit cost and analysis, which is like on this column. So you're basically calculating whether the defense is effective or not. Then you calculate the storm probability, and then you use the damage avoided as the potential benefit associated with this particular project. Then what we're suggesting is that you must account it for the ecosystem benefit by characterizing the ecosystem improvement, and then all the ecosystem service value needs to be included. And then to the right of the screen, there are several examples. So the two very popular types of green option is wetland. Then the ecosystem service values per acre per year is actually very high, and then compared to the cost. So this is this component. Then, in contrast, we heard about the oyster reefs and stuff. From my reading and the review of the cases, in the literature, the cost it's also quite high. But what's unique about the oyster reef is they grow with the sea level rise. So you usually, you invest in oyster reefs. It's take care of it. Basically, it regenerates itself, accommodating the rising sea level, which is the major advantage of this option. So several case studies. We heard about the Boston shoreline protection projects and the designs. So we actually collaborated with UMass Boston and Woods Hole Group as well. We heard many times today to evaluate the 3 project sites in East Boston. And I'm not going to get into the details, but basically it's documented, in the cost for the gray option is lower than the green option. So then this is the additional cost associated with the green option. However, once you factor in the ecosystem benefit, the benefit to cost ratio are all greater than 1, which means the benefit is actually greater than the cost. And then to the right, it's another useful website that's for the state of Maine, specific location in Maine. It's basically ranked the sites in terms of the energy level. So usually the living shorelines would work the best in the low energy location. And if in the high energy places, many projects failed is because they mistakenly putting the green shoreline in a high energy area. It's not going to succeed. So a quick summary on the green infrastructure. I'm not going to go through all the list, but 3 take-home points. One is living shoreline is not only a good idea, but it's a good investment. And then I think the second point is that we need to focus on, which is the last point on the list, the benefit to a private individual is often different to the general public because the recreational benefit, a lot of other benefits, they are actually really for the public. So that leads to my next second component or part of my talk, which is my colleague and I, so they work in the geology department and the economists here in our Marine Policy Center. We work together on what we call the geoeconomic model. In essence, it's a combination of the geomorphological models, which is the pink color circle. It's basically simulating the movement of sediment. And then the socioeconomic model is a model the investment decisions of homeowners. And then in one of the earlier works, we actually showed, there is a huge benefit associated with the coordination. So in other words, if the neighbors, they coordinate and then on project, then you can show through their action and then simulated through geomorphological models, the net economic benefit is much higher. So the payoff is great to coordinate. And then another one is a bit on the theoretical side in the geological model is the choice of managed beach width. I think if I understand it correctly, in the bylaws nowadays, there are mandates for certain, the protection should be like 20 whatever times of the erosion annual rate, something along those lines. So on the picture to the right, you can see that you can nourish to the wider beach. Or this is either unnourished or you keep it at a lower level. So the model basically saying, what's actually the socially optimal or optimal to the homeowners. So I'm not going to get into the model itself, but the results, there are actually 3 key points. I think it's important. They're all kind of obvious. So the beach width is negatively correlated. So in other words, if the cost is higher, nourishment cost is higher, or construction cost is higher, then you can only afford a narrower beach. Then the second point, the same thing is true with the discount rate. So discount rate is showing on this particular plot. So the horizontal axis is the beach width. The vertical axis is the discount rate. So you can think about low discount rate is when you think about, I'm investing not only for myself, but for my grandchildren. Now, for the higher discount rate is suggesting I'm just thinking about myself, about to retire, then, it's not going to, I don't need it very long. So in other words, you can see as you actually lower your discount rate, you're thinking about multiple generations, future generations. You want to invest more, wider beach. However, what's unique about this model is that most of the simulation models, they are deterministic, meaning they don't consider uncertainty. Then in this model, we consider the uncertainty. Again, the horizontal axis is the beach width. And our uncertainty level is in the vertical axis. Then you can basically see that, for a given risk perception, as you increase the uncertainty, the beach width actually going to decrease. So the take-home point is that, people think about, protecting their homes or communities, so they want to nourish beach way out. So here is the uncertainty associated whether this project is going to be in place, whether it's reliable. So for example, if you're investing in the living shoreline, project in a high energy area is going to be washed away in a few years. That's highly uncertain. So that's the types of uncertainty I'm talking about. So you want to pick the reliable options that's going to last for very long. If that's the case, you invest more, and then to have greater level of protection. So you basically ended up with a trade-off. Like you really want to protect your home, so you want to nourish out more, but then you want to make sure it's going to stay. If it's not, then you're probably not going to nourish that much. So that's another point. I think it's a take home of this geoeconomic modeling. Then the last case study is the work that we work with University in New Jersey, and they look at a more complex structure. The modeling idea is pretty much the same, but what's different here is after Hurricane Sandy, they have this public funded sand dune. Then there's a berm in front of it. So the dune, the higher, the greater protection, but that is blocking the beautiful ocean view. So then through the model that you can see, depending on the value of the homeowners to the ocean view, they're actually having different optimal dune height. And so what you're going to see is that although the Army Corps finance this miles after miles of this sand dune, but the homeowners behind it, they have different preference. So those are the points, I think. So would affect future, because I think the Army Corps financed the initial construction, but I forgot, after certain number of years, it's actually the town is going to be responsible to keep the dune in place. So back to the two options. So I think in one of the best paper I read, which is, I think it's from the National Academy of Science, they basically suggesting the shoreline change response strategies should be really viewed as what they call the sustainable hazard mitigation, in that you're thinking about reducing the very long-term risk, to human life and then to property. Then I think, as a planner, I would, break the whole thing down into two. If I'm thinking about the next 30 years, I would, considering the green-gray options, all that, but in the long run, eventually, I think a relocation is the only option, because the sea is going to, like from our keynote this morning, there's no way that we can stop this. So in the very long run, after 30 years or longer, I think the response is to choose where to build, how to build, where to locate, and so that's basically the lesson I learned from my research and the literature. Thank you very much.
And I've got the pleasure of introducing this last but not least session of today's conference. So first up, we've got Margot Mansfield. Margot is a coastal hazards and climate specialist with Massachusetts Executive Office of Energy and Environmental Affairs, and a colleague with me at Mass Coastal Zone Management. Margot provides technical support to EEA's climate team, Municipal Vulnerability Preparedness Program, and CZM's Storm Smart Coast team. Please welcome Margot.
So this is the last session.
Yes.
And so good afternoon. I'm happy to be here to kick off this last session on climate action planning by sharing some insights of
an ongoing statewide initiative to update the Massachusetts State Hazard Mitigation and Climate Adaptation Plan, or SHMCAP. So I'd like to start by just going over some terminology, because in this space of climate planning, like the term mitigation can have many meanings. So hazard mitigation is any sustainable action that reduces or eliminates the long-term risk to people and property from future disasters. Hazard mitigation planning can break the cycle of disaster damage, reconstruction, and then repeated damage and loss. For the context of my presentation, when I'm referring to climate action, I'm specifically referring to climate adaptation, which is the process of adjusting to current or expected changes from climate change. When we bring these two perspectives together, we are promoting more proactive planning to reduce our risk to natural hazards and a changing climate. Massachusetts released its first integrated hazard mitigation and climate adaptation plan in September of 2018. Developing and maintaining these plans has several benefits, including limiting damage, disruption, or loss to buildings, infrastructure, and natural resources. It helps reduce risk to natural hazards that might be exacerbated by climate change over time. It increases the ability to bounce back after disasters. It provides a shared understanding across the Commonwealth or region of interest of what those relevant hazards and climate impacts are. And it helps Massachusetts and its communities obtain funding for hazard mitigation and climate adaptation projects. So this brings us to why we need a state hazard plan. An approved state plan is federally mandated for Massachusetts to maintain its eligibility to access the Federal Emergency Management Agency, or FEMA, pre- and post-disaster hazard mitigation assistance funds. Local hazard mitigation plans are also required for localities to maintain their eligibility to these federal funds. And these FEMA-approved plans must be updated every 5 years. So the state's current plan is going to expire in September, and so we are in the final stages of updating it to maintain that eligibility. There are several sources of funding through FEMA, and this chart here shows the distribution of the approximately $91 million that Massachusetts and its communities have received since 2010. Most of the funding has come through the Hazard Mitigation Grant Program, or HMGP, and that's shown in the gray wedge of this chart. These funds become available following a presidentially declared disaster, and typically the funding amounts are about 15% of the total dollar damage amount. The next largest wedge is from the Pre-Disaster Mitigation Program, or PDM, and this is a legacy program that has now been superseded by the BRIC program. This is represented by the blue wedge, just making sure the colors are showing correctly on the screen. So BRIC, or Building Resilient Infrastructure in Communities, some key elements of this program include incorporating nature-based solutions, including those designed to reduce carbon emissions, and also a focus on climate resilience and adaptation. The smallest wedge here is from the Flood Mitigation Assistance Program, or MFA, and funding through this program is to reduce or eliminate repeated flood damage to buildings insured under the National Flood Insurance Program. The Massachusetts Emergency Management Agency, or MEMA, serves as the pass-through for the FEMA grant programs to eligible subrecipients, as illustrated in this chart. So state agencies in yellow, private nonprofits in gray, and municipalities in blue. Federally recognized tribes are also eligible, similar to states, but they typically seek the funding directly through FEMA rather than going through MEMA as the pass-through. State agencies and private nonprofits typically use FEMA funding for studies, project scoping activities, or assisting municipalities with their local hazard mitigation plan updates, but not for construction activities. Though the majority of projects in Massachusetts do tend to go towards culverts, drainage upgrades, or other local flood reduction projects. And those eligible project types include construction or capacity building. This map shows a subset of the 300 or so projects from the previous slide to illustrate where those infrastructure projects are going across the state. And the legend here is for the number of projects per locality. So 1 is in blue, 2 projects in green, 3 projects in orange, and 4 projects in red. So now that we've gone over some of the terminology, some benefits of what these plans are, and the funding, or some funding avenues for implementation, let's get back to what this plan actually is. First off, MEMA has developed and maintained a state hazard mitigation plan since 1986. In 2018, MEMA and the Executive Office of Energy and Environmental Affairs, EEA, launched a partnership to integrate climate resilience planning into the state hazard mitigation plan in response to Executive Order 569. This integrated state hazard mitigation and climate adaptation plan, or SHMCAP, was adopted in September of 2018, and it was a nation-leading and recognized effort. The SHMCAP was responsive to Executive Order 569 in that it included agency vulnerability assessments, it outlined regular plan updates, and it dedicated Secretariat climate coordinators to monitor plan implementation. The 2018 SHMCAP was also a model for local climate resilience planning to assess and evaluate current and future risks. So I mentioned that we are currently updating the 2018 plan. This 5-year update is pulling from the recently completed Massachusetts Climate Change Assessment. And I'll touch on this a bit more, but essentially, the 2023 plan includes a more extensive assessment of climate data and impacts to inform agency assessments and development of adaptation actions. The SHMCAP is also leveraging the extensive stakeholder engagement carried out through the climate assessment to inform those agency actions. So a key part of this update is updating those hazard mitigation and climate adaptation actions that the state can carry out for the next 5 years. And finally, the SHMCAP is responsive to the latest FEMA planning policy guide that takes effect this year. Throughout the development of the SHMCAP, the goals underwent a series of review, bringing in input from state agencies and others, and the team landed on these 6 goals centered on collaboration, communication, funding, and engagement, science-based and informed decision-making, resilient state assets and services, and implementation of adaptation actions for communities and ecosystems, consideration of climate mitigation when designing hazard reduction actions, and resilient and equitable infrastructure, ecosystems, and communities. So these are the main components of the SHMCAP. The state capabilities and capacity identifies capabilities and key challenges for agencies to implement these hazard mitigation and climate adaptation projects. 90 new capabilities have been added since the 2018 plan, and these include new coordinating structures, new data and tools, and new funding sources. The next 2 components are closely tied and are leveraging findings from the climate assessment to evaluate risks to state assets, services, and programs and populations served. And then I've hit on this a few times, but a big piece of this SHMCAP is the action and strategy, and I'll touch on that a little bit more detail in a moment. But finally, the SHMCAP includes a framework for implementation and yearly maintenance. So some of the earlier presentations have hit on some of these hazards. This slide here shows the 16 hazards that are included in the risk assessment. Many of these are leveraging the data and findings from the climate assessment where there was a clear tie to climate change. New to the 2023 plan is the inclusion of looking at changes in groundwater as an emerging risk. And so in the 2023 risk assessment, the concepts that are covered for each of these hazards include looking at the geography, so the geospatial reach of these hazards, looking at the likelihood of occurrence considering climate change, looking at the magnitude of consequence of the impact and the ability to respond, looking at adaptive capacity and disproportionate impacts, and looking at the vulnerabilities across the sectors that are outlined in the climate assessment. So I mentioned it several times. Here it is. This is the climate assessment, the report covers. So from left to right, we had Volume 1 is an executive summary. Volume 2 is a statewide report, so this is the main piece of the assessment. And Volume 3 are the regional reports. The climate assessment utilized the latest statewide climate data to address impacts from climate hazards, so these being extreme heat, flooding, and drought, and looked at these across 5 sectors and 7 regions across the state. The sectors include human health and safety, infrastructure, natural environment, governance, and economy. And you can see that Nantucket is part of the Cape Islands and South Coast region for this assessment. So the assessment identified the top impacts per sector, identified as most urgent based on magnitude of consequence, disproportionality of exposure, and adaptation gap. Volume 3 of the report really digs into the regional summaries, and what you're seeing here are the top impacts for the Cape Islands and South Coast region. The green boxes here are highlighting those impacts that aren't a top impact statewide, but more specific to this region. And that includes the increase in vector-borne diseases within the human sector, reduction in clean water supply within the infrastructure sector, and coastal erosion within the natural environment sector. So I do encourage you to check out the report, especially Volume 3, if you want to dig in more to these regional findings. The state uses the SHMCAP in several ways. It uses it to identify those hazards that pose the greatest risk to Massachusetts, to identify critical assets and services, to guide priority actions to mitigate those top hazards, to set statewide priorities and develop programs to implement at the statewide, regional, and local level, to assist local municipalities undertake their own hazard mitigation and climate adaptation planning, and to implement projects to reduce risk. The state can point to the hazards in the strategy both to seek and grant money for project implementation at the state and local level. The action and overall mitigation strategy is responsive to those top priorities that are identified in the plan. The actions were evaluated for consistency with the goals. And for this update, the action are organized by those priority impacts set by the climate assessment. So this slide shows a spectrum of the different action categories in the plan. The overall strategy is centered around the following themes: collaboration and support of a whole of government approach, focus on the most consequential hazards, resilience building through conservation, restoration, and management, and a focus on environmental justice and other priority populations. As shown by this simple schematic, there is a reciprocal relationship between how communities can or are using the SHMCAP and how the SHMCAP can then use those efforts at the local level to inform plan updates and implementation strategies. Hazard mitigation planning at the local level provides information and data about critical community assets. They also provide critical information on the local experience of hazards and damage from past events. And the SHMCAP then can provide additional data and hazards and information at the statewide assets to help align planning and investments and decision-making to mitigate those hazards. Communities are also using the SHMCAP by bringing in the data and strategies into their climate resilience planning through EEA's Municipal Vulnerability Preparedness, or MVP program. In response to EEA launching this program in 2017, over the past 5 years or so, we've seen several communities begin to integrate their hazard and climate resilience processes. There is a new FEMA local HMP policy guide that does require integration of climate and equity. While not a requirement of the MVP program, it is very encouraging to see how climate resilience is continuing to be a stronger part of the conversation when we're talking about approaches to reduce our long-term risk to natural hazards and how climate change may be exacerbating those. As you can see by the map, nearly all communities in Massachusetts are participating in the MVP program, shown by the blue shading. And further, the orange dots here show the widespread effort across the state to implement actions, implement projects identified in those local plans. So I want to close my talk today by just sharing some resources to help with hazard and climate resilience planning and implementation. I'm sure many of you are aware of the Resilient MA at mass.gov Climate Change Clearinghouse website. This is a living resource that has evolved over the years to feature the latest statewide climate data, hazard data, and guidance to assist resilience planning in Massachusetts. If you go to the Learn header, you'll see there's a link to that recently completed climate assessment page. We will be rolling out some additional resources to leverage the findings of this report, so do stay tuned to that page. Once we finish the SHMCAP, we'll be linking to the plan here as well, and then there'll be some web content updates, including an updated action tracker to see how and what those state agency actions are and how they're progressing over the next 5-year cycle. If you go to the Take Action header, you'll see there's a link for the MVP program. There are new resources here to support the launch of MVP 2.0, which is focusing on addressing the root causes of social vulnerability and helping communities move from planning to implementation. And then finally, if you go to the Tools and Data header, you'll see a link for our relatively new Maps and Data Center page. Here you'll find a map viewer featuring the latest climate projections that are used in the climate assessment and the SHMCAP, including components of the Massachusetts Coast Flood Risk Model, MCFRM. I know we had a couple of presentations earlier today that had mentioned it. It's quite a large data set, and there's many different components, so it's definitely a space that we'll be building out over time. This Maps and Data Center also has an interactive climate change projections dashboard, which includes a feature to look at future extreme precipitation. So you can look at estimates of rainfall volume for design storms under future warming scenarios. So just one last plug on the MCFRM. This past spring, EEA and CZM, with support from Woods Hole Group, completed a 3-part online training series for use of the MCFRM. It was designed both for beginner and advanced users. It looked at details of the model, an overview of the available public products, and guidance on application and some hands-on experience. If you've missed these trainings, fear not, we did record them, and they are accessible on EEA's YouTube page. So I'd like to thank you for your time. I wanted to recognize the co-leads of the SHMCAP, Mary Beth Groff from MEMA and Maya Mansfield from EEA. And just a reminder that we do have the RMAT at mass.gov inbox if you have any follow-up questions. Thank you. Great. Well, stay tuned for the final plan this September.
Okay, next up, we've got Liz Durkee. Liz has been Martha's Vineyard Commission's first climate change coordinator since December 2020. And last year, she helped guide the development of a 20-year Vineyard Climate Action Plan. Before working with the commission, Lynn was a conservation agent in Oak Bluffs for 22 years. And way back in 2011, she wrote a 15-part series for the Vineyard Gazette newspaper looking at the specific impacts of climate change on the vineyard. So she knows what she's talking about. Please welcome Liz.
Short person. Thank you, Steve, and it's really nice to be here. Thank you, everyone, for having us here today. Yes, I've been kind of obsessed with climate change for a long time, and I was very privileged to be able to take part in developing the Climate Action Plan for the Vineyard. The Vineyard Way, connected to our past, committed to our future. It's a 20-year regional plan, and like the Nantucket Coastal Resilience Plan, over 100 local people with various areas of expertise helped develop it. It was funded by the MVP, and we hired a local consultant. We wanted someone who knew the island. We didn't want someone from far away coming in and trying to tell us what to do. So I want to get into some pieces of it. Oops, there I go again. There's several chapters. I'm only going to go over a few of them. I just wanted to acknowledge that the land and water that this plan is based on is the traditional land and water of the Wampanoag tribe. I'm going to do this again. Nope, I didn't. What motivated us? We have a climate action task force at the Martha's Vineyard Commission, and they have an energy working group, and they put together some baseline information on our emissions. We emitted 606 million pounds of carbon in 2018. That's the kind of emissions information in the plan, and then we looked at hazards like rising temperatures, wildfire, flooding, sea level rise, etc. At our kickoff meeting, we developed 5 guiding values for the plan. The first one was healthy natural resources, equity and inclusion, community collaboration, which is another word for acting regionally, which is kind of a dirty word on the vineyard, but we're trying to change that. Resilience building is, we want to try and be as self-sufficient as we possibly can, being an island, looking at our energy and our food and our waste. And local action really means that everyone on the island needs to take part in this. It's really a community effort. Part of the MVP grant program for climate action planning is community engagement, and we kind of went all out on this. Before we even got the grant, we did over 20 stakeholder meetings to find out where people were at in terms of their understanding and needs concerning climate change. We did a lot of outreach. We had 6 thematic working groups, and we had over 40 planning meetings over the course of 9 months, all but the final one over Zoom, which had its pluses and minuses. We met with 93 town officials and volunteers. We met regularly with the selectmen, and we had a climate action week, an entire week of climate action events, talks and field trips, and then a finale where we had an EV parade and booths, and it was really a big success. Because it really made people aware, no matter where you were on the island. I'm sure you had to hear that there was this climate action week going on, so it just raised awareness. Even if people didn't actually attend any of the events, I think it maybe clicked something. So we split the plan into 6 thematic areas, and they are land use, natural resources and biodiversity, transportation, infrastructure and waste, public health and safety, economic resilience, food security, and energy transformation. And I can say those in my sleep. So I'm going to go through the land use section to give you an idea of how the plan is designed. At first, we look at what the issues are in each area, and in this case, coastal erosion and flooding, salt marsh loss, degraded water quality are some of the issues that we are looking at. We developed some baseline information. 313 buildings are going to be permanently flooded by, I think that says 2030 or 2050. I can't see it on here. 3 to 5 feet of annual erosion on the South Shore. And here's a really scary fact. 7,400 new houses and 9,000 guest houses could still be built based on current zoning. That's a lot of natural land being disturbed. So it's good to have baseline information. We tried to look at equity in terms of each of the 6 thematic areas. Obviously, wise land use helps everyone. Another equity issue is the big socioeconomic divide we have on the islands. That was a tough one. We debated whether or not to include housing in this plan, and then we really decided that although it's all interrelated, that's not really a climate issue, and we wanted to keep our focus on climate change. So we did not address that. We also asked some questions because this is the first climate action plan. We don't have all the answers. We want the community to start thinking about things like, should we allow people to build in areas that we know will be unsafe in the future? So getting people to start thinking about these issues is a big part of this. In order to implement this, we have measures of success that we're looking at. But first, I want to just go over the 3 goals in this land use category. The first one is that land use decision-making prioritizes public safety and ecosystem values. The second one is that natural resources and biodiversity are cooperatively managed and protected. And the third is to protect our coastal ponds and sole source aquifer against increasing pressures. So some of the measures of success we included are the number of new or updated land use policies adopted, habitat corridors created, adaptation strategies implemented, number of acres of salt marsh restored or mitigation areas protected, that type of thing. We included individual and town actions that can or should be taken in each thematic area. In terms of individual actions, one of these is to reduce the size of your lawn, plant more native species, conserve water. And an example of the town actions are updating our floodplain and wetland bylaws and regulations to address climate conditions and current climate science. This is the gist of the plan. For each thematic area, there are several goals. Under each goal, there are several objectives, and under each objective, there are many actions. There are over 200 actions in the entire plan. And I think one of the smartest things our consultant had us do was to assign a lead agency for each of the actions. And that agency is responsible for implementing that action. And that includes conservation organizations, public safety groups, a whole variety of, it's really a community effort. The Martha's Vineyard Commission is the lead in many of them, and myself and our energy planner are working to implement those actions. And we're overseeing all the other agencies who are working on other ones, but I think it was really important to have a lead agency for each action. There's a due date for each one and a cost estimate, and many of these actions have co-benefits. For example, supporting aquaculture, helps clean the ponds, it's a traditional food source, and it creates local jobs, so that sort of weaved its way through several of the thematic areas. So I'm just going to go through some of the actions included in each of the areas. For land use, natural resources, and biodiversity, the actions include discontinuing or managing development in vulnerable areas, preserving salt marshes for their many values, setting maximum disturbance limits for new development and standards for the use of native plants, and protecting coastal pond water quality and our drinking water. Transportation and infrastructure. we on the, yeah, okay. Actions include planning for the protection or relocation of critical vulnerable roads, collaborating with the Steamship Authority to build resilient port infrastructure, and assessing supply chain vulnerabilities, and also reducing our solid waste. Public health and safety actions include bilingual community outreach to the public and to healthcare providers on health-related climate issues. We just issued a survey to healthcare providers on the island to try and understand what their level of knowledge is on climate-related health issues. And so that will help us understand where education needs to proceed. Development of an island-wide emergency preparedness response recovery plan, implementing our new regional community wildfire protection plan, and another action here is to hire a full-time permanent regional island-wide emergency manager. For economic resilience, I think it's safe to say that diversifying the economy is a big issue. Training residents for climate-related jobs such as salt marsh restoration, green infrastructure, and then energy jobs like heat pump installation, solar installation, things like that. Keep the money and the people here in the local economy. Ensuring the transition of vulnerable businesses. Food security includes developing standards for climate-friendly farming practices, ensuring a consistent food supply in place for the food insecure and during emergencies, increasing access to lands for the indigenous community, and increased aquaculture production and support for careers in commercial fishing. And finally, energy transformation actions include increasing efficient electric home heating, the use of EVs and solar energy, more microgrids and battery storage, advocacy for the transition of ferries to electric power, which is more of an issue on the Vineyard, I understand, than on Nantucket, collaboration with Eversource for grid capacity, and assistance for low and moderate income when it comes to energy transition. We have 3 overarching goals. The first one is a framework for land use decision making. This is a little difficult to explain. We're going to be having overlay maps. We're going to look at we're going to hopefully get a new map of the island vegetation, overlay that on, say, on our transportation system so that when we make land use decisions, we make them wisely. And for example, if we need to move a coastal road inland, we're not putting it in a place that's an important habitat corridor. So we're kind of looking at the big picture there. We're looking at a sustainable source of funding for all of these 200 actions. We're looking at something like some sort of green fee that some other island communities around the world have developed. And we're looking at capacity building for climate action. We really need more people working in the climate field on the island. One thing we really feel like we need right now is a climate communications specialist, because all this work is being done by so many people on the island, and the general population needs to be aware of it so that they can understand and take action and buy into these projects. So that's one of the many jobs we need. Some of the things that we really intend to implement this plan, and we talked about that before we started the plan. We don't want this to be a plan that sits on a shelf. And I think one of the biggest things we did to help that along is have each action have a lead organization responsible for implementation. And the due date and the estimated costs and the measures of success, the commission's overseeing implementation. Each of the thematic working groups that worked on the various issues are meeting biannually to update each other on what they're doing. We have an implementation spreadsheet, and we have a website where we're going to be updating our implementation. And we have a committee made up of the MVC and members of each of the town climate and energy committees that meet monthly to help collaborate and talk about what we're doing and help move things along. Community awareness and support. I've given this presentation a lot of times around the island, trying to get people to understand what we're doing. The radio station just did a really great 5-series panel discussion called Walking Through the Climate Action Plan. And we really were excited about that because we addressed some issues that we feel like we really need to start a dialogue about in the community. For example, managed retreat from the coast and impacts to the local economy. And if you're interested in seeing those, they're on the WHOI radio website. They were Zoom discussions. They weren't actually physically verbally on the radio. We work with the newspapers, the Island Climate Action Network. We were present at an Earth Day festival. The High School Protect Your Environment Club has student climate cafes where the students pose questions to the community about climate issues. So we're trying our best to get all this information out to the public, and we just had our first annual Climate Action Fair this year. We didn't do a Climate Action Week again. That was a lot of work. So we're going to be having annual Climate Action one-day fairs, and that was a big success last month. And here are just some pictures of the Climate Action Fair from last month. The theme was Reduce, Repair, Renew. We had bike repair stations, we had sewing stations where you could learn how to repair your clothes, we had solar consultations, we had people outside with their EVs talking about what they liked about them. We had over 25 organizations with booths, and it was just, there was a really good feeling. I think, you know, I think the understanding of what we're doing is growing, even though sometimes it feels like we're not getting that far. So here are some of the CAP actions that are underway. The Climate Action Plan came out last summer, and some days I go to work and I feel like I'm not getting anything done. But when you look at the big picture, you know, slowly but surely things are happening, and a lot of these projects in the plan are underway. Ascend Nantucket Salt Marsh Study, microgrid ID sites, the Vineyard Power, our local vineyard cooperative, has energy coaches now that residents can call and find out how to get rebates for solar panels and EVs and, you know, all those things that you think about doing but you don't know where to turn when you want to look for the information. I mentioned the healthcare survey. We've put together a vulnerable populations task force. There's quite a few things happening. It's kind of encouraging. And the Martha's Vineyard Community Foundation has developed a climate action fund where we're encouraging people to donate money so that we can start to build a fund to be able to implement more and more of these actions. So thank you for your time. The Climate Action Plan can be found at thevineyardway.org if you're interested in learning more about it. So thank you very much. No questions are fine. Thank you.
Okay, so our last presentation of the day, I'd like to introduce the brave man who's agreed to do that last slot, which is always hard. Probably most of you know him, Vincent Murphy. Vince is the town of Nantucket Sustainability Programs Manager and a recent appointment to this newly created position. This is a kitchen sink role that includes a bit of everything, from coastal resilience to energy and historic preservation, and his particular favorites, quality of life on Nantucket and climate action planning. Developing a climate action plan is a chief concern to read to the global issues of climate change at the local level, where Nantucket, too, is playing its part to understand and reduce greenhouse gas emissions as a community. Vince.
All right, get the technicals right first before I break something. Here we go. This looks about right. Yes. So luckily I'm up last. This might be a little on the short side, and I think people might actually appreciate that given that we've had a very long day. I've heard a lot of wonderful things here today. Some of it's going to be repetitive, and it's very hard to go after Margot and Liz because I'm going to be kind of a little bit repetitive because they covered a lot of what has to be done, what the state is doing, what other organizations are doing similar to ours, such as the whole island of Martha's Vineyard. So I like a tagline for things. We need miracles. Quite literally. So So this is a lot of extremely obvious stuff, but let's everyone just have the same base information and just kind of start with the same problems, just in case there's people watching this after the fact, high school kids, everyone just wants to be on the exact same page, and it's a big thing to try and explain to a room of professionals that work in these fields. So climate change, source problem, increased greenhouse gas, mainly carbon. So this comes with a whole host of associated problems. This is very similar to a slide Margot had, and these are things that we spent all day talking about because they're coastal resilience related issues. But all of these, in some way or another, or a lot of them, come in for the climate issues for Nantucket. We could have everything from ocean acidification, increased air temperature, drought, agriculture loss, habitat loss, property loss, it just keeps going. We could just add to that list all day long. So now that we understand that, we need to understand some of the background of what might have happened on Nantucket in the past. So let's just put it all on a timeline and start working it out. In 2011, we had a Nantucket energy plan. 2018, we had our hazard mitigation plan that was done through Planning and Land Use Service, effectively our building department. We had a very nice greenhouse gas assessment done by WHOI, Worcester Polytechnic Institute. That was done in 2020, and I'm going to be using information from that. And we had our coastal resilience plan in 2021 that Leah now is in charge of. So just to look through some of these things, initially the Nantucket Energy Plan was meant to be a climate action plan. It was rewritten to be an energy plan. We could have had one 12, 13 years ago, but it wasn't accepted by the select board at the time after it was rewritten as an energy plan. But it's still a very useful plan. It's still a good starting point, a launch pad for us to move forward from. We had a wonderful student-led project for the greenhouse gas emissions, a great inventory of sort. And we had 2 town plans that help with aspects of climate change. They're related problems, but not the whole issue of climate change. This has led to us where we are now, looking to develop a climate action plan for the island, and this is going to be the point of an MVP grant application that was submitted by the town in May. So from the student-led project from WPI, we have this wonderful graph here that is nice and technical. I have a simplified version of it next. There's numbers in this that just give a good estimate. I wouldn't put massive stock in this because things like, we'll go back one. Construction are 0.0%. That just doesn't seem right on Nantucket. So pinch of salt in this one. The big thing to take away from it is that they came up with a rough estimate of 141,000 metric tons of carbon dioxide equivalent. That's from all kinds of sources, everything from electricity through gasoline, airport fuel, propane brought on island, everything brought into one number. And the biggest one, according to their research, was 48% was for residential buildings, almost 24% for passenger vehicles, and about 16% for building and manufacturing. When I read the report, it kind of sounded more like restaurants. So just to look at this in terms of, well, what does this mean? Great. We have a big number that looks for carbon dioxide equivalent in metric tons for a whole island, and I had trouble making sense of it. So I looked to compare it to other places to see what that meant. Arlington, also in Massachusetts, had about 284,000 metric tons. And with to make that sense of that, I tried to make it a tonnage per capita. So every person in, say, Nantucket has about 9.9 metric tons per person. In Arlington, that works out at 7.8 metric tons per person. And then in Natick, another small town, about 8.8 tons. Wonderful. What does that mean? Still lost. So I had to bring it to the national level and look at what it was for the whole US. So just in metric tons per capita across the whole US, this includes like Puerto Rico and other outlying territories, it's about 13.8. But there are some states that are way worse. And kind of when you look at the map, northern states are pretty bad, probably because colder winters, and trying to deal with heat in the summers, that kind of thing, bigger climate shifts, and that makes places like Wyoming have 96 metric tons per person. That's the worst. But one of the best was DC itself, Washington, D.C., and that was 3.5 metric tons per person, and that was about the best on the list that I was looking at. But then for the rest of New England, just to get an idea, places like Maine were about 9.9, which is very similar to Nantucket, Connecticut, 9.4, Rhode Island, 9, and Massachusetts as a whole, 7.4. And I then heard what Liz said about 606 pounds of carbon per person on, total, 606 million pounds of carbon on Martha's Vineyard, and I tried to work that out, and that didn't make sense. I must have missed a zero somewhere, because I came up with 16 metric tons per person, and that's kind of high. That seems wrong. And that was the back of an envelope, Liz. I wasn't trying to say anything. So I wanted to understand what this meant, and I'm still having trouble with it, if I'm honest. So if we looked at this 141,000 metric ton carbon dioxide as it was from the 2020 survey, what does this mean? If we just brought all of this from all the different sources down to one thing and looked at it just as the gasoline equivalent, it's about 16 million gallons of gasoline. I can't imagine what that looks like, so I did what every good American does, and I turned it into Olympic swimming pools. 24 Olympic swimming pools of gasoline. And that's enough, just in case anyone's curious, to drive 363 million miles in a standard car. Then if you looked at that same thing, it's just electricity, I had fun with this one. It's enough power for 27,500 homes just for 1 year. That kind of makes sense in terms of Nantucket, but not when you think about it in terms of just cell phones. So it's enough to charge 17.2 billion smartphones. Again, there's a problem in this because there's only about 6.8 million smartphones in the world, but we can charge all of the smartphones 2.5 times just for all the power in Nantucket. Other equivalents that I found hilarious were 17,800 homes for mixed energy. This is propane, electric, home heating, all that kind of stuff. About 6.5 million cylinders of propane for your grill, and only about 0.3 of a natural gas-fired power station for 1 year. So it would actually take about 3 Nantuckets to get 1 natural-fired gas station. So the whole point of this is very simple. The numbers are mind-boggling to the point of being abstract and useless. So it's hard to keep the numbers being meaningful. So this is one of the things when I go to develop a climate action plan is I want to have meaningful numbers in it. That's my point. Essentially, this just comes down to the fact that we use a lot of energy here in Nantucket and we produce too much carbon. So what about our sources of energy? Where does our energy come from? We know a lot of this inherently on the island, but let's just put it out there so everyone's on the same page. So electricity generation in Massachusetts comes from 192 different power stations. Most of them are quite small. And Massachusetts consumes about twice as much electricity as it generates. That's an interesting one for our state and our security. We produce as a state 18,200 gigawatts, and I just wanted to put it in terms of kilowatts just to help myself. It's about 18 billion. And about 3/4 of all the electricity produced in the state comes from natural gas power plants, which is really good in terms of carbon offsetting, and then other things like solar, biomass, and hydroelectric make up the remainder. Oh, and if you add all these stats up, it's 102%. Thank you, state. So what about Nantucket's electricity? That's the next big question and what people want to know about. So we know some of this. Our main electric source comes from our 2 undersea cables. But we also have a developing solar economy, and we have two locations on island, on town property, one at the sewer department where we've just recently got solar installation, and we're looking to get more at the Wannacomet Water Company. So our undersea cables, there's 2 of them. Cable 1, the Lathrop Avenue station, that can take roughly 36 megawatts of power, and cable 2 coming from Merchants Way station does about 38. Not necessarily what the islands use, but that's kind of our capacity in those cables. And that means we're limited, not like other communities. So the normal demand in 2015, when these numbers are from, is about 20 megawatts. going through those cables at any time. And the peak happened in 2015. In 2015 was 45. This was in the summer. And that's for our electricity, but our liquid fuels, the other great consumption we have on island, diesel, gasoline, propane, aviation fuels, all that, is brought here to Nantucket by barges or on ferries without passengers. And if you want to just think about that, it's about 39,000 metric tons of carbon equivalent. It's about, and if it were all gasoline, it'd be about 4.5 million gallons. It's just, the numbers I just find hilarious. All right, so now we're on the road to a climate action plan. So we need to think about this properly, and we need to look at it at all scales, not just what the state is doing, which we've heard about and is terrific, but we start at the global. And I'm sorry, I have trouble with this all the time. International Panel on Climate Change. I have to say it to myself every time because it's not the Irish Peatland Conservation Council. Several reports come from them about the impact on adaptation and vulnerability. They've also got a mitigation for climate change, and they're just constantly producing more. Margot covered all of this. Then at the federal level, we've also, what Margot talked about, for the climate action plan, the EPA's climate action plan, and the federal sustainability plan, the Biden plan for sustainability. The state, which has already been covered, is just producing so many reports, so many useful reports that we're going to be able to use, take, and learn from and implement. And there's more on the way in, I think, September. And you also heard about the SHIMCAP, which Margot and Liz, I think, mentioned as well. But this is the thing. The Vineyard has it, we don't. What's the fastest way to get anything done on Nantucket? Say that Martha's Vineyard has it already. So what's our climate action plan going to look like by the time we get to it? So I did a grant application earlier this year to MVP, and this was the rough structure of it. So just at the very high level, we're just going to do the obvious. We're going to do the background research. We're going to get lots and lots of public involvement and community engagement. We're going to undertake a really comprehensive greenhouse gas inventory. This is not against the WPI students. They did terrific work, but there's always that lingering problem in the back of my head. Did they get an A+ or a C-? So we need to do a really quality inventory to understand what we actually use and understand where we can actually make improvements. Then we're going to have a best practice toolkit. This will be similar to what we already did in the Coastal Resilience Plan, and I'm already borrowing ideas from what Martha's Vineyard has done. We're going to work towards a decarbonisation roadmap, and I'm going to talk just a bit more about that in a sec. And we're going to have our final report. This is just the massive overview of the structure, and it's a very simplified version of what this grant structure is going to be. There are sub-tasks to each of these to work through. The application went in early May, and we find out in August if it was accepted or not, but we have to find a way to pay for this because our town, our island, our county desperately needs a climate action plan. This is some cautionary questions, and I don't know if I have answers at this point, and I'd happily take advice from Martha's Vineyard on this one. In reading about other places that have this kind of work done, this is kind of the after-action review kind of stuff that comes up. Did it work? And here's what people kind of asked after the fact. Can Nantucket work towards decarbonisation? I'm replacing other town names with Nantucket here. And then just looking at our community, we have what could only be described as a very luxurious lifestyle here with a high carbon usage. Will the community accept a decarbonised Nantucket? That could be a tricky one. Most places that set targets for decarbonising or reducing carbon on their day-to-day usage, they miss deadlines. They miss what they're supposed to do. So we have to really think what's realistic. And once we already saw a climate action plan in the 2011 timeframe that didn't get work, we already know we're up against challenges. So learn from what has happened before to make improvements in the future. So I talked about miracles at the very start, and I brought it in there again. We need to look at our island's past. We've got our lovely historic island here. We need a green future. And this is why we need miracles, because it's an acronym. Making island resources a collaborative local effort for sustainability. We need this. We need to make it work together. We need to do it. So just understanding the basics of sustainability, and this is like a very simplified version of this. And you always see this as either a Venn diagram or it's just like the 3 pillars of sustainability, but it comes down to these 3 things always. Environment, economics, and equity, sometimes called the social aspect for equity. So this is to understand what we can do to get wins in all 3 of these areas to make our island more sustainable. Thank you.
Any questions?
When do you hear about your grant results?
Yep. The question was, when do we hear about the grant results? August. This coming August. Fingers crossed, touch wood. Anyone friends looking state? Hi, Molly.
So you sort of did the carbon emissions per capita, but obviously we know that people here aren't emitting kind of equally. Will the more specific, if you get the grant, will it kind of delve down into kind of biggest emitters on the island and get some of that data, or?
The question was about refining the data, and will we be able to drill down to look at who is using the most carbon on island? Is that about correct? So I should hope so in some form. So this is, every society is unequal, and this has extravagance in it, and extravagances in our society that are just slightly more on display than in other locations. So it would be good to try and understand that. In reality, the number I had for Nantucket was based on our census figure, 14,255 people. Nantucket Data Platforms has a different population assessment from 2017, a couple of years before the census, where there was about 17,000 people. And the reality is we still don't have a good clue of, we don't have a good picture today of the numbers of people that are coming and going to Nantucket on a daily basis or on a monthly basis to understand what our actual population is. To answer that question is somewhat of a greater question, but to understand what each sector of our, say, community contributes, that is a more realistic way of approaching it. And that's the way I hope would be a nice way to hit it. All good? Thank you, everyone.
All right, well, we made it. We made it to the end of the agenda. I want to thank all you guys for staying to the end. I know it's tempting to sneak out after lunch or as the day goes by, but I think it's really fair to the late people presenting. Before we take off, I just want to say thanks to a few people. First and foremost, the presenters. It takes a lot of time to put those together and to come up and take time out of their busy days. So thank you all the presenters. Also the folks that did the posters. That's a great addition to the conference this year. I'd like to take time to thank our conference sponsors, including the Nantucket Land Bank and the Nantucket Conservation Foundation. They contributed financially to help keep everyone fed and caffeinated, so we really appreciate that. And also especially to the Atheneum. They give us the use of this space for no fee, and that really allows us to do a free conference, which includes lunch. So please let those folks know that you appreciate that community support. Also the conference partners, including the town of Nantucket, Barnstable County Extension Service, WHOI Sea Grant, and Mass Coastal Zone Management. Also NCTV to help us live stream this in spite of technical challenges. And finally, to all the attendees, you guys are why we do it, and we really welcome your feedback, the good, the bad, everything. And usually we send out a post-conference survey, so if you have time, do that, or feel free to just email Leah Hill or Shelley McComb. Their names are on the agenda. You can shoot any feedback and any suggestions. We do this every other year. We go over to the vineyard one year, and then we come back here. So we're always looking for ideas on emerging topics of interest. So other than that, thank you for taking the time out of your day and being with us today. Take care.